Tradoon. 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 Tradoon, Tradoon.
Ontogeny. Glue is cheap. Ontogeny.
Tradoon.
Girder.
Tradoon.
Ontogeny. Glue is cheap.
now recognize that birds are dinosaurs, what I study is the long, deep evolution of birds from Mesozoic dinosaurs.
The very concept is unimaginable. Why, if that happened, we wouldn't have a chance. How could we possibly hope to fight them?
We couldn't, you're right. You're right, Mrs. Bundy.
Hurry up, children. Finish your lunch.
Are the birds gonna eat us, Mommy?
Birds have been on this planet since Archaeopteryx, 140 million years ago. Doesn't it seem odd that they'd wait all that time to start a war?
Who said anything about a war? All I said's...
Troodon probably fed on our ancestors, the early mammals.
It is the most intelligent, adaptable, and successful hunter on the planet.
Look at the gap.
That's not bad for a quadruped. You gotta check your mirrors, just the side of your eye. Side of your eye.
Success.
Well, hello everybody, and welcome back to Paleontologizing. It's really good to have all of you here today. I'm glad you could join me. We're gonna have a fun and rather special stream today. We're continuing our countdown of our new dinosaurs described this summer. We went through 4 of them yesterday. We're gonna do the next 5 today, 9 in total. 9 new dinosaur genera were described while I was out in the field this summer, between the beginning of June and mid-August. So, yeah, I'm excited to learn about them with you and look at the original papers in the scientific literature as well. But for those of you who are here for the very first time, and it looks like there are a few of you, welcome to Paleontologizing. Allow me to introduce myself. My name is Danny Anduza. I'm a dinosaur paleontologist. You probably know already that a paleontologist is a scientist who studies fossils. I work on dinosaur fossils in particular. I study them, I publish on them, I dig them up in the field. That's what I was doing for the past 2.5 months out in Wyoming and then Utah. And we were streaming that also. So again, if it's your first time here, then check out the VODs or check out the YouTube page to see the fieldwork live streams. Anyway, normally on this channel, when I'm not out in the field, we're going over some of the latest publications and news from fossil science, with a strong focus on dinosaurs, of course. Doing some 3D printing also. Right now I'm 3D printing a life-size Allosaurus skull. So we'll be assembling part of that in a little bit also, because I've got some parts that finished printing yesterday and this morning. And yeah, we also do 3D modeling and illustrations. I'm working on some new publications and stuff. Going to be interviewing other paleontologists and doing a lot of Q&A. So if you have any questions, then please do not hesitate to ask them. That is really the bread and butter of these streams, is viewer participation. Questions from people watching. So don't be shy with those. Anyway, welcome to Paleontologizing. It's great to have you here. Let's see who's here in the chat right now. Let's see. I'm glad you guys liked the cold open there, though. Yeah. We didn't have these in the field, so it's nice to be back in the office to be able to play these again. But, yeah. SB says, don't be fooled, Danny is not a dinosaur, he's a human paleontologist. I do not work on human fossils. I work on dinosaur fossils, hence dinosaur paleontologist, but you know what I mean. Yeah. Tommy Lucas says, I think you should do an interview with a dinosaur. I've done a few of those when we did zoo streams, you know? We put the microphone right up to some birds' beaks and see what they had to say. Maybe we could do that again sometime soon. But yeah. Anyway, and Claire Berg, great to see you. Hi, Smorphosaurus. Tommy Luco, thank you for that gift sub. I appreciate that. Smorph, are you doing okay? I heard that you had to, thought I saw in the chat you had to evacuate because of a fire nearby. I really hope everything's okay. You hang in there, Smorph. Appreciate you being here. Hopefully we can take your mind off things a little bit. Welcome back. And Wondergoon, I am doing well. Thanks for asking. It's great to have you here. Yeah. Me and my family had to evacuate our home due to a bad fire. I'm sorry to hear that, Smorph. Shoot. I hope everything's okay. I hope it's just a precaution. But yeah. Anyway. It's good to see everyone here. We might just go ahead and start off. Unless anybody's got any questions. Don't be shy with those questions. Now that we've got a few minutes before we actually get into any of our activities. But I'm working on 3D printing this life-size Allosaurus skull. There we go. It's gonna look like this when it's finished. Yeah, very excited about this. And we're already... It's going faster than I thought it would. I thought this might take all autumn in order to finish. But holy cow. We've already got the lower jaw. Let me go grab that. There we go. Yeah. Here is lower jaw, dentary, angular, surangular. Splenial is in there somewhere. Big ol' lower jaw, and then here's the other half of it. I actually need to reconnect these. But, holy cow. Am I excited about this. And then here is our skull so far. We just put this on here. I think these are, what, the nasals? The anterior nasals on right there. And we've got a few more parts that we're going to put on. So, yeah. And it is indeed life-sized, Espy. It is indeed. Yeah, Grilled Pikachu says, why is it so shiny? Because it's made of plastic. It's 3D printed. You know? It's not the real fossil bone. But, yeah. Yeah. And I am... Oh, shoot. I needed to check on this. Is it still going? Because we're going to run out of filament pretty quick. I got to change it out to a different spool. And it's got to be a different color because we've run out of this color here. Yeah, let me do that. Hang tight, everybody. Let me get this swapped out. Boy, that could have gone badly. We could have lost that whole thing if it's had completely run out. We'd have to start over again. Because it'll just try and dry print it with no filament in there. So I'm really glad I caught that when I did. Yeah. Anyway, good stuff. And Delano, very funny. Shoot, these 3D prints would not last a season out in the field. They would immediately get UV damaged and start to fall apart. They'd even start to melt a little bit in the sun. PLA filament is not... It does not do well outdoors. It really doesn't. But yeah. Thank you, HD and HB. It's great to have you back, by the way. Good to see you. Yeah. And, Ken, how are you doing, Ken? Welcome, welcome. Ken was out on our field crew with us, for anybody not familiar. Ken says, I need to somehow incur a life debt upon someone with a 3D printer to make me one of those, or preferably a Ceratosaurus. Ken, did I show you my Ceratosaurus Halloween costume that I made a couple years back? There we go. But I had to design and then print a Ceratosaurus skull specifically for this. Yeah. Hello to you too, Ken. It's good to have you back. Man, this is taking forever to load. What's up with you, Instagram? Yowza. Let me just get the skull and show you. There we go. Yeah. So it turns out there are some available, like, 3D models of Ceratosaurus skulls, but they're all too narrow to fit a human noggin into at any kind of reasonable scale, and so I had to design a special one with a space wide enough for my head. I do, and widen the whole thing. Yeah, it fits in like, just like that, and this was all in the service of a Halloween getup, which I'm trying to load for you right now. And, Instagram just will not load. Ugh. But yeah. And Smay says, are those different kinds of filament? I always wonder if my company would make 3D prompts of a few things for our field crews. Yeah, this is PLA filament that I'm using right now, which it's usually the cheapest of all of them. And the easiest to print with, which is why I use it. But it looks pretty good when painted. There we go. Here's the Instagram, and there is my Ceratosaurus costume. Yeah. It was, Ceratosaurus skeleton costume. Good stuff. It's one of my favorite Utah dinosaurs. Ceratosaurus is a pretty cool critter. Kind of the last of its kind. And one of the biggest of the Ceratosaurians. Unless you count a Bellysaurus. But yeah, that was a ton of fun to do. But yeah. Why don't we go ahead and start putting this Allosaurus skull together. By the way, Allosaurus and Ceratosaurus are two dinosaurs from the same time in the same place. They're what we call coeval. There we go. Allosaurus is usually a good deal larger than Ceratosaurus. But both these dinosaurs lived at the same time in the same place, the late Jurassic Morrison Formation of Utah, Colorado, Montana, Wyoming, and probably South Dakota also. I think they've been found... Actually, I'm not sure if Ceratosaurus has been found in Montana or South Dakota yet, but Allosaurus has been found in all those other states. Yeah, Allosaurus is far more common than Ceratosaurus, too. And then there's a third dinosaur, a third meat-eater from the same formation, Torvosaurus. And we're not really sure why you could have three gigantic meat-eating theropods all in the same time in the same place. Are they doing some niche partitioning? Is it sort of like how in on the African Serengeti today, you have lions and leopards and cheetahs all at the same time in the same place. But they all kind of do different things, you know? Leopards hang out in trees and they ambush their prey and then carry it back up into trees. Lions have these big groups out on the savannah. They're very social. They're kind of like the Allosaurus in this situation, I guess. Yeah, Allosaurus is the most common of these three meat eaters in the forest. Then Ceratosaurus, you know, must be doing something different from Allosaurus and Torvosaurus. Kind of like leopards and cheetahs do something different from lions, so they can all coexist in the same environment. I'm excited to see ideas like this tested in the future as we get more fossils and we have more talented, bright, young paleontologists working on this stuff. Speaking of which, our friend Ethan Cowgill, pull up a photo. Ethan is actually working on Torvosaurus. And he is describing a brand new skull of this animal. There's Ethan right there. After he's all clean shaven. He's holding Jim's plaque. But Ethan is working on Torvosaurus. He is currently describing the most complete skull of Torvosaurus in the entire world. We can finally figure out what the skull of this animal looked like in detail because we have pretty much all the parts of it now. And so Ethan's working on that. I think he'll be presenting that at the Society of Vertebrate Paleontology meeting this fall in Cincinnati, Ohio. Yeah. And Ken says, then Saurophaganax, the Big Al. Yeah. Saurophaganax might be the same genus as Allosaurus, though. I was talking with Jim about this. It's basically just like a supersized Allosaurus.
Here's something stranger than science fiction.
Might be later in time, too. Vixen Lixon, thank you for the follow, and welcome to Paleontologizing. It's good to have you here. Yeah. But yeah. And Glitchy, yeah, Cincinnati is where SVP is going to be held this year. Let's see. Society of Vertebrate Paleontology. There we go. The Society of Vertebrate Paleontology is the professional organization for vertebrate paleontologists. And the annual meeting is in Cincinnati this year. Which unfortunately, I will not be able to attend this year. But that's because, well, any guesses, maybe? Any guesses in chat as to why I might not be able to attend SVP this year?
We didn't come here to fight with monsters. We came here to find fossils.
It's true, Pete Martin, and I'm glad you're here too. Welcome to Paleontologizing. You'll find a lot of fossils here. I won't be on a dig. Lack of money, great guess. That's what's kept me away from SVP many times in the past, but not this year. I'm not going to the moon. We're not waiting for the Great Pumpkin, Weird Adult. If you said that I'm going to be at TwitchCon, and you were correct, I'm going to be at TwitchCon this year. Unfortunately, TwitchCon happens to be the same exact weekend as SVP. 52 weekends in the year, and it has to be the same one. Ugh. But anyway, so I had to make a tough decision. Am I going to do SVP this year? Or am I going to do TwitchCon? SVP was going to cost me a ton of money. I'd have to fly out there. It was going to be a lot. TwitchCon, I can drive to Vegas, and it might not cost me very much at all because there might be something special and cool going on which I can't talk about yet. But it's going to be neat. So if you're going to be at TwitchCon, you might see me. Yeah. So I'm excited for that. It's going to be cool. I'm not going to wear the Ceratosaurus get up there, but I might have something even cooler. HD. We'll see. Yeah. And $540 it hurts, says Ken. I mean, yeah. That plus a flight? Oh boy. And a hotel. But yeah, anyway. I'm going to be at TwitchCon, so if anybody would like to meet me in person, well, that's the time and the place to do it. But yeah, TwitchCon is going to be so much fun, Lordy. Lordy's going to be going too, so pretty excited about that. Emilith says, not enough vertebrate paleontologist streamers to make them schedule appropriately. Need to fix that. We do need to fix that, yes. So yeah, yeah. Don't they know paleontologists are poor, says HD? I mean, yeah, but SVP also does not have a lot of money, so money's got to come from somewhere. Maybe next year we ought to rob a bank or something. Make SVP free for all attendees, or presenters at least. Anyway, let's go ahead and get this thing assembled, shall we? And will I be streaming from TwitchCon? Sort of, Cactus Jack. Sort of. Yeah. This is what we have so far for the skull, and we've got a couple of new pieces to put on here. So let's go ahead and do that to start off the stream. This piece right here and this piece right here are our new ones that we'll be putting on. And let me show you which bones these are. Let's open up our revised osteology of Allosaurus by Jim Madsen, who was once the state paleontologist of Utah in the days long before Jim Kirkland.
If you're feeling a bit cheated, try blaming the dinosaurs.
I often do there, Stink. Thank you for the 100 bits. Appreciate that very much. I think this page 68 or something like that. There we go. That's what we're looking for. So, this element right here, these are the nasals at the top of the skull right there. Part of the nasals, at least. They extend downward. This part's already on there. So we'll be attaching this, the nasal bones, and then part of the posterior maxilla as well. So the back of the, this big tooth-bearing bone right here. And let me show you what those look like on a human skull, just to give you some frame of reference there. The frontals. Let's see. This is tricky because they might not actually be called the frontals on a human skull. They might be called something else. Oh, no, there we go. Yeah, I think those are the frontals right there in yellow. And then this is the maxilla, which I think might have a different name also. And human anatomy, everything's got to be, like, super special and unique, you know? It's honestly kind of annoying. They can't just use the same names that we have for every other animal's bones. But anyway, yeah. So this is going to be basically this part and this part that we're assembling today on our Allosaurus. So let's hop to it. Yeah. Put this on my desk pad so as not to get adhesive all over it. There we go. Let's turn our volume, turn our light volume up a bit. There we go. Yeah. Let's get our adhesive out. This is gonna go pretty quick. And it's still the maxilla in humans? Maxillofacial surgery? You're probably right, Subamf, yeah. Well, but in humans, there's just one. I think the maxilla is a fused bone in a human skull. I don't think you can really see the suture there anymore. And the premaxilla is actually what I'm thinking of, where that has a different name, and that got, like, shunted up into the skull. It's, like, up in the sinuses or something somewhere now. Anyway, human skulls are weird. There we go. Let's do our frontals first. So, this. It's gonna fit on just like that. Beautiful. So we've got some really nice contacts there. I'm gonna put some adhesive along here, and then in here also. So let's do it. There we go. And again, I'm using this 3D gloop, which is gifted to me by Patrick Pirate and Engine Nerd. So thank you again for that. This stuff has been super, super useful. I like it a lot. It's my new favorite adhesive for 3D prints. Works fantastically with PLA filament. Just holds it right on there. And let's put a little bit on here also, just for good measure. And there we go. Make sure this is sealed so it doesn't spill. And I just got to hold it on there, put some pressure on for a few seconds. And, yeah. Excellent. And HD and HB says, did dinosaurs have the same little ear bones, and are there fossils of those? They did not, actually. You're giving me an excuse to talk about something really cool. Mammal inner ear bones are super weird and special. And dinosaurs did not have them. There's just one bone in the inner ear in dinosaurs, and we have three. The Malleus, the Incus, and the Stapes. But yeah, dinosaurs were not like that. Mammals are unique in that regard. So we can talk about that in a minute or two here. That's actually one of the things that defines mammals and makes them, like, unique and weird and special, is those inner ear bones. Because they used to be part of the lower jaw. The bones that you're listening to me with right now, those bones you're using to hear in your inner ear, in your distant ancestors, those used to be part of the lower jaw, but they got shunted up into the skull. So we'll talk about that. But first, let's get this on there. So that, I feel good about that. That's gonna stay. And this one, our posterior maxilla should fit on just like that. Beautiful. Yeah. Very nice. This is so big it's gonna be hard to fit in frame, but we'll make it work. There we go. Do mammals have better hearing than reptiles? They often do. Baha, yeah. Yeah. Here, I'll talk about that in a minute. We'll get to it. But first, let me just paint on this blue. There we go. Nice. Now let's get this attached. What? Sorry, hit the soundboard there. There we are, very nice. And yeah, mammal hearing is so good that some evolved echolocation. Absolutely, Grilled Pikachu. Mammals have, as a group, generally speaking, mammals have incredible hearing. And that, a big part of that may have been living in the dark, either in burrows or coming out at night during the age of dinosaurs. Because the way you got to remember it is, for the majority of our history, mammals have been kind of living in the shadow of dinosaurs. Mammals first evolved around the same time as dinosaurs, in like the middle to late Triassic, about 240 million years ago, something like that. And then until 66 million years ago, they were basically under the boot of the dinosaurs. They were mostly small creatures, inhabiting pretty much only small-bodied niches, kind of living in a world ruled by the dinosaurs. They were certainly outcompeted by dinosaurs in all of these larger-bodied animal niches. So dinosaurs were just much, much better at being big and coming out during the day. Yeah, stuff like that. Mammals were not as good at that. And it took an asteroid to kind of give mammals some space to get big. It took the extinction of the non-avian dinosaurs to do that. Alright, very nice. Oh yeah, that's shouldn't have tried it there. This is good. I'm gonna put a little bit more glue on, maybe? No, it's good like this. I can do more glue later. I'm just gonna set this down and give it some time to set up. There we go. But let's talk about mammal ears. You can use those beautiful mammal ears, very sensitive mammal ears, to listen. I think it's in here. Yeah. Here we go. Excellent.
Contains almost all of the North American identified specimens of Troodon.
Of Troodon. Thank you, Fiery Faye, for the follow. Thanks for following, Fiery Faye. Welcome to Paleontologizing. It's good to have you here. Let's talk about the origin of these wonderful mammalian ears that we have. Here.
From high pitch, a new kind of ear.
Yeah.
The hearing anatomy of mammals is unique. You won't find ear flaps on any reptile.
I guess that's true.
Our ears are extremely sensitive, allowing us to pick up a wide range of sounds. From high-pitched squeaks to low-distance calls.
Okay.
And the secret of their incredible sensitivity lies in the tiniest
By the way,
bones in our body.
that was Roger Smith right there. Yeah, the low frequency call.
From high-pitched squeaks to low-distance.
So yeah, I sat next to Roger Smith during the conference, the Mesozoic Terrestrial Ecosystems Conference back in June. On the last day, I think I spent much of that time sitting next to Roger Smith, and it was cool because he would take notes on like every single talk. He's very diligent about absorbing all the information there. I was just kind of letting it wash over me, but he was writing everything down. Cool guy. And Fiery Faye, hey, it's great to have you here. I'm glad you could be here. I hope you stick around and let me know if you've got any questions. That's what this is all about, you know? Yeah, but right now we're talking about mammal ears and why mammal hearing is special, how it first evolved.
And the secret of their incredible sensitivity lies in the tiniest bones in our body.
These are the three bones of our middle ear. All mammals, including people, have these three bones that sit inside the skull. And what they do is they form a little lever system that turns the vibration of air into sound that our nervous system can perceive. We, like all mammals, have three of these bones in our middle ear, but reptiles only have one.
Yep.
These two extra bones, the malleus and incus, enable us to amplify sounds that reach our eardrum.
Pretty cool, right?
Which is one reason why our hearing is so much better than reptiles.
It is generally better than the hearing of reptiles, including birds. Well, sort of. Except that in some reptiles, including birds... Oh. Afro Bandit Girl, thank you for the 12 months of support. Yeah.
1 year already? Whoa, still having a good time. Nice to have ya safe back home, Danny.
Thank you.
It was fun watching the dig this summer.
It was fun digging this summer. I'm glad you enjoyed watching. It's great to have you back. Thanks for your ongoing support. It means a lot. Anyway, the hearing of mammals might be more sensitive than that of most reptiles, including some birds, but it's more susceptible to damage because you've got moving parts in there and they're actual bones, so they don't heal very well. And later on in life, a lot of people go hard of hearing, they lose their hearing. That's because over time those moving parts just kind of break down, from what I understand.
The situation called for still more protection.
And Robo Oso, thank you for the follow.
Spears which projected from his body armor.
That means robotic bear in Spanish, everyone. What a cool name. Thanks for following. Anyway, birds, in order to hear, they've got the stapes bone, I think. But they also have like these microscopic hairs that sense the vibrations in the air, and those can heal really well. And so birds usually do not go deaf with age in the same way that a lot of mammals do. Yeah.
This presents us with a simple yet extraordinary puzzle. How did our acute sense of hearing using 3 bones emerge from our reptilian ancestors who used only 1?
Yeah, and this is also a little bit, whoa, what was that?
2 centuries.
Misleading because, and I can't believe that Neil Shubin is like, it's one thing that I don't like about this series is that, you know, he keeps saying that mammals evolved from reptiles, which they didn't. Reptiles and mammals are entirely different groups, and we've known this for probably like 30 years at this point. So it's kind of a really old, outdated idea, and I don't know why. Maybe he thinks it's simpler to frame it that way, but mammals and reptiles have been separate since the, you know, they're split at like the base of amniota. Mammals did not evolve from reptiles. Like, we both evolved from a common ancestor, but mammals have never been reptiles. Does that make sense? Yeah. But yeah, and did synapsids have the advanced ear bones? They started to develop them after a while, Steely Dan, yeah. I actually just ordered a book about that Fisher from our field crew recommended to me, because he's a big synapsid, therapsid guy. And he read this book called Beasts Before Us that he really, really enjoyed. And he's like, Dan, you got to read this. I'll let you borrow it. I'm like, thank you, Fisher. I want my own copy. So I just ordered that yesterday, and hopefully it'll be here soon. But anyway, yeah, the evolution of mammals is really interesting. I don't know enough about it. It's going to be fun. Yeah. And MLF says, so the reptilian brain thing is not particularly factual? No, it's not. Not at all, MLF. Yeah. It's not.
Scientists have been fascinated by this mystery.
But this is super cool. Oh, man. I actually showed this to Fisher this summer.
Karen Sears.
So
this is such a cool experiment.
The gray short-tailed opossum, and they have been used in labs for a few decades and are now becoming a much more popular lab organism. They're very cute. So the opossums, like other marsupial mammals, the mother gives birth very early compared to what we would call placental mammals, things like us, like mice, like dogs. So these guys, you know, they're a month and a half old, they're pretty big. When they're born,
they're just a little flesh bean when they're first born.
A real mean kid. With 6-inch daggers for teeth.
Shishimi.
Terror of his neighborhood.
Thank you for the follow. Welcome to Paleontologizing. It's good to have you here. And thank you for the hydrate, Devin Verzra. Look at those baby opossums. These are like almost newly born. They're just like little pink jelly beans, basically. And I think they'll show you a close-up. They're basically like embryos that are outside of the mother. It's crazy.
and they're only a few millimeters in length at that stage. They are almost at an embryonic stage of development. About the equivalent of a human embryo at about 40 days of development. So they don't really have hind limbs.
Look at that.
They have no hair. They can't hear at all.
That's what they look like when they're first born. They're just a little fleshy bean. And then that development takes place outside the mother Isn't that crazy? Yeah. So, why does this matter? What does this have to do with the mammalian ear? Well, you're about to see. It's really, really cool.
Try blaming the dinosaurs.
And Miss Yvette, thank you for those 100 bits. I appreciate that. Yeah.
At that point.
Oh, and being with claws, that's the thing, Emeleth, is that the one thing that a marsupial embryo absolutely has to do when it's born is it has to be able to crawl its way out of the birth canal up into the mother's pouch, or at least onto her belly to get to a nipple there to be able to start drinking milk so it can develop outside the body. So that's why they need limbs like this. You absolutely need little grabbers so that when you emerge from the birth canal, you can crawl your way up. That's like the first thing that you have to do as a newborn marsupial. Yeah.
These opossums are born just 2 weeks after mating. And
Holy cow.
can see how their ear bones form at each stage of development.
And happy late birthday, Miss Yvette. Hope you had a good one. Yeah.
In order to find the bones, she euthanizes the opossums and uses flesh-eating beetle larvae to strip away the
dermested beetles.
Dinosaurs had not died, perhaps in some catastrophe.
Time scroll,
No
thanks for the
reason to think
follow.
Dinosaurs wouldn't still be here, wouldn't still be dominating the Earth.
Welcome to Paleontologizing. It's good to have you here. Yeah.
These dermested beetles are used by labs and museums the world over.
I've used dermested beetles before. They're pretty standard.
It takes about 24 hours for them to complete their work.
But they leave these beautiful, clean skeletons like this.
Karen is then left with a series of skulls through which she can trace the development of the middle ear bones from embryo to adult.
This is super cool because it basically...
And what the skulls reveal...
It retraces the evolution of the inner ear bones, like from when they're in the jaw to when they're up in the inner ear. That's something that these animals are doing as they grow and develop. From an embryonic possum to an adult possum, it's doing the same pattern throughout its life. That's ontogeny recapitulating phylogeny, we would say. Super, super cool.
Reveal is astonishing.
So what's really surprising is if you look at these early opossum embryos, what you see is essentially a reptilian style ear with one ear bone. Those two extra middle ear bones, they're going to...
Mm-hmm. This is like we have on our Allosaurus here, where you've got, you know, here's the tip of the jaw, there's the teeth there, and then you've got these different bones in the back. This is the dentary, the big tooth-bearing bone right here. But then you've got these other bones in the back, and I kind of wish these were color-coded so you can see, but there's multiple bones back here. As mammals, we only have one bone in our lower jaw. That's it. Dinosaurs have, I think, 4 on each side of the lower jaw. And baby opossums have the same thing, but watch what happens.
Be in the ear, in the adult, they are part of the jaw. And so the jaw joint between the skull and the jaw really looks like that of a reptile. Then after they're born and while they're growing up, those little bones that are going to be the mammalian middle ear disconnect from the jaw. They get relatively smaller and move up to their final position to become a mammal-like ear.
Yep, there you go.
So if you have...
That's wild.
Reptiles with one ear...
So this is not happening, not just, you know, over tens of millions of years. That's what happened with the ancestors of mammals developing into modern mammals. But that same process is repeated every time there's a baby possum born that grows up. Isn't that so cool? I think that's amazing. Yeah. And Baja, is that the bone that allows snakes to open their jaws? So why there's kinesis between all the different bones in a snake's lower jaw. So yes and no. Yeah. What they have is like flexible spaces at the symphysis of their jaw and then back there too. So yeah. Yeah. That's absolutely incredible. Isn't that cool, Chippermonk? Yeah. Yeah. And Ken says, a baby us too. Does it happen the same? I guess it happens in a human embryo. Yeah. Yeah. But yeah, shoot, when you were a tiny little embryo, the bones in your inner ear used to be part of the jaw. And then during development of you as an embryo, they got shunted backward and then upward into the skull to become the inner ear bones. Super cool. Yeah. Does this happen in all the mammals? Pretty much, Emeleth, yeah. Yeah.
You have
well, in marsupials, it's particularly evident because you can see it after they're born, because they're basically born as a little embryo. But yeah.
Other mammals with 3 ear bones. I think what the embryos do is they almost provide a link between those two.
Yeah.
So what we see in the opossums is from that time they're born through their adult, they almost go through 300 million years of evolution in terms of their ears.
Pretty cool. Pretty cool indeed. Yeah. So yeah. That's... In fact, I was talking about this with Fisher a bunch of times this summer, because he's a mammal / therapsid / synapsid guy. Yeah. Trying to find you a decent graphic to help describe this. Yeah, so the bones that actually form the jaw joint are different in, There we go, yeah, excellent. That'll work. Here's Dimetrodon up here, who is not a dinosaur. Procyon, Probetonathus, Morganucodon, and Monodelphus. So up here in mammalian ancestors, you've got multiple bones in the lower jaw. And then eventually, this one right here, the denary, it actually just turns into the entire lower jaw in advanced mammals. Yeah, or in proper, crown group mammals, I guess you would say. And so these ones that used to be part of the lower jaw, the green guy right here, the angular bone, becomes the tympanic bone up here. Pretty cool, right? Yeah. Anyway, good stuff. And Ruler says, if part of the jaw splits off and migrates to the ear to form the basis of hearing, might it be possible to replicate that same process later in life to treat hearing loss? That's an interesting question there, Ruler. I wonder. I doubt that would work itself, but, that's a really interesting question. You're thinking like a scientist. That's super cool. This is how, basic scientific research, studying the evolution of ears might actually help cure diseases someday. Putting this really fascinating but somewhat arcane stuff to, practical use. That's the thing. When you study paleontology, you never know what kind of, spin-off benefits that might allow in the future. That's the value of basic scientific research. And that's something that I really wish people like politicians could get through their thick skulls, When you fund basic scientific research, not only are you stimulating the economy, and inspiring young people to get into science, which is a positive in and of itself, but there's going to be cool spin-offs that you can't even imagine. Things that will improve society in ways that you never would have dreamed of. So again and again, that's what we see in the history of science, and yeah. Anywho. And Kelladon K, welcome back. It's good to have you here. I feel like it's been a while. Yeah. I think there are inner ear plants available that replace those bones, but don't quote me on that. Interesting, Kelladon, huh? Yeah. Yeah, and if only, Afro Bandit Girl agreed. Yeah. But yeah. Oh yeah, and Kelladon K, I actually, when I was doing, summer science camp, I taught a kid who had cochlear implants, and he had, this permanent headphones type thing that wrapped around the back of his head. And, yeah, that was cool. He was a funny kid. He was, by far the youngest kid in the class. I'd come up with this dinosaurs class to be, 3rd and 4th grade. And he was, just going into 1st grade. But he was sharp. Yeah. But he was a funny kid. I remember at one point, I asked him how old he thought I was for some reason. I don't remember how it came up. And he looks at me and he's like, nah. He goes, 89. 89. I'm like, you think I'm 89 years old? And he's like, you have a beard. Yeah. Yeah. Anyway. Good stuff. But yeah, kids are fun, Lenina. Do we know why politicians evolved such thick skulls? They didn't. I think politicians might be elected based on their thick skulls. At least that's not evolution. That's it's like a weird kind of artificial selection. That usually doesn't carry generation to generation, thankfully, but sometimes it does. Anywho, yeah. If anybody else has got any questions, now is the time, because we're going to jump back into our new dinosaurs. Just a few minutes here, I think. Yeah. But yeah. And Chippermonk says, kids will say the most shady things, fully unintentionally, and with their full chest. Oh yeah. Believe me, I taught kids for a number of years, and the things that kids say about their parents are sometimes really off the wall. Or just, I don't know. A tamer example would be, I remember one time, just out of the blue, like, we're sitting there coloring or something like that, and, yeah, the little girl turns to me and she goes, Teacher Danny, my mom doesn't have a uterus anymore. This is like a 5-year-old girl. I'm like, whoa, cool. That's pretty neat. It must have been something that she'd been talking about with her mom over the weekend or something. But yeah, it's like I didn't need to know that. Not like it matters, you know. It's all cool. But it was just pretty funny. Just completely out of the blue. Apropos of nothing. Oh, and Mia Miyakota's got a great question. Thank you for bringing this up. What's the deal with Brontosaurus? I was reading things that the name may be being reused with the genus or something. So, Brontosaurus is the genus, Mia Miyakota. Yeah. There we go. I've got a command for this. Thank you, Claire Burr. Maybe we can pull up a video. Is there a good video about this? Let's see. Oh, shoot. Here's Betsy talking about this. I went to school with Betsy Kruk. This video is from when? From 9 years ago. Things have maybe sort of changed a little bit since then, but let's take a look.
Whatever happened to the Brontosaurus? Remember the cartoon character Fred Flintstone? And how he used to drive a Brontosaurus at work every day? There sure must have been a lot of Brontosaurs living around during the time of dinosaurs, right? Not a single one. The Brontosaurus never...
Oh boy, don't say Brontosaurus never existed. Please don't say that. Don't say that. Don't say that.
Right? Not a single one. The Brontosaurus never actually existed.
Oh boy. So this is really misleading. It's not... Maybe she'll salvage it here, and I kind of doubt that she wrote this. We'll see. I don't know. I'm trying to give Betsy some credit here. It's not that the dinosaur itself never existed. It's that name for it might be unnecessary, because it had another name first. Essentially, the same dinosaur got named twice. And according to the rules of zoological nomenclature, the name that gets published first is the one that stands. However, it gets a little bit more complicated because there were two different specimens. One, you know, there was Apatosaurus and then there was Brontosaurus. Apatosaurus was named first, so that's the name that we would keep. But it turns out, some scientists nowadays think that the Brontosaurus specimen is actually different from the original Apatosaurus specimen. Ignore those quotation marks. The Brontosaurus specimen might actually be different from the Apatosaurus specimen. And so maybe it actually does deserve its own name. There's controversy about that right now. Anyway, let's see how the rest of this goes.
And was in fact an incorrectly identified dinosaur that was created by putting together the body of an Apatosaurus
That's not true.
with the head of a Camarasaurus.
Oh boy, that's not strictly speaking true. The Camarasaur type head doesn't actually have anything to do with the naming of Brontosaurus. It doesn't. Oh boy. Oh boy.
You can learn this and many other interesting facts in Dino 101. Register today.
So that's not the greatest. Maybe this one will be better.
Brontosaurus is a name that we all grew up with, but actually since 1903,
there we go.
It's been regarded by vertebrate paleontologists as the junior synonym of Apatosaurus.
So there we go. That explains it. We think the same dinosaur was accidentally named twice. Like somebody thought, oh, this specimen, it's got a few minor differences from this one. It must be a new genus. We'll call it Brontosaurus. But it turns out, no, it's probably the same thing as Apatosaurus. So when that happens, when it turns out that one thing was accidentally given two names, like one species or genus of dinosaur was given two names, you go with the older name. That's the one that has priority.
So Apatosaurus is what most of us consider to be the correct name for the animal that we all know as Brontosaurus. Brontosaurus was a sauropod dinosaur that was described in 1879 by Othniel Charles Marsh at Yale University. And it was described from a very complete, very well-formed adult animal. And several of the characters which he used to distinguish it from a previously named dinosaur that he named 2 years earlier, Apatosaurus, is that it had 5 sacral vertebrae. These are the backbones in between the hips. They fuse together and they provide a firm foundation for supporting the hind limbs. In Apatosaurus, which we now recognize was maybe 2/3 grown, that type specimen, that was a young individual, its
and they hadn't fused yet.
Vertebrae hadn't all fused yet, so it only has 3 fused sacral vertebrae. So those are the some of the.
So again, what do we call this, chat, when creatures change throughout their lifespans? That's not evolution. That's what happens between generations. But what happens? What do we call it when? When a creature. Thank you. Ontogeny. Very important. Yeah. So it turns out that it might actually just be an ontogenetic difference between Brontosaurus and Apatosaurus.
So it only has 3 fused sacral vertebrae. So those are the some of the characters that Marsh used to distinguish Brontosaurus from Apatosaurus. In 1903, Riggs studied that, and he described those as a part of a growth series.
And Elmer Riggs is the guy who named Brachiosaurus, by the way.
And so they are not valid to separate species. They describe different stages in the growth of one species. So Riggs synonymized Apatosaurus with Brontosaurus. So
it's not that Brontosaurus never existed. It's just like, shouldn't have given this animal a new name, given that it's just Apatosaurus, you know? That's the thing. Like, I'm really, really leery of ever using the phrase like, oh, this dinosaur never existed, when you have so many people on the internet nowadays who have TikTok brain, and they're like, they're not sure that they believe in dinosaurs at all, you know? You don't want to give any fodder to those people. Especially if you're a scientist, because they will clip you out of context and they'll just go running around trumpeting that all over the internet. So does that make sense? Yeah.
So since 1903, Brontosaurus has been the junior synonym of Apatosaurus.
Yep. There you go. So that's a much better explanation. That's from 6 years ago, but it gets more complicated because, yeah, here we go. Brontosaurus is making a comeback. We'll see if that's any good. I'm not sure. 8 years ago. Let's try this. Let's try it.
The Brontosaurus was a dinosaur we all loved. Then we were told it wasn't real. But now it's back.
What's going on?
Good question. Yeah. So I'll just tell you right now, so you don't think I'm getting this from the video. There's a paleontologist by the name of Emmanuel Schopp. And Emmanuel went around to a bunch of different museums and looked at some of these original sauropod specimens. And he tried to figure out, like, just disentangle this big taxonomic mess. Like, all of these different dinosaurs that have been given different names. How many of these actually are different from one another? What can we really say with any certitude? That kind of thing. And he's like, well, shoot. The Brontosaurus holotype actually does seem to have some differences with the Apatosaurus holotype. It might be an actual valid genus, which means that name should come back. But his methodology is, not everybody agrees with it, because if you go by his methods, it would be like almost every single specimen of a sauropod dinosaur would have to be its own species. If you're treating these minor differences as being indicative of different species or different genera. But anyway, I haven't actually read the paper in full, and so I might be a little bit, I don't know. Don't take my opinion here as gospel or anything. Talk to some other people who actually work on sauropods for a more informed point of view. This is not my area of expertise within dinosaurs, but yeah, that's my view.
Hi everyone, Crystal here with more D News. What picture pops into your head when I say the word dinosaur?
Oh, for me? What picture pops into my head when you say the word dinosaur? Probably this one.
Tradoom.
There we go. It's a callback to yesterday. When you say the word dinosaur, this is what I picture. This is a silky chicken. Birds are dinosaurs. Anyway, I'm just being kind of goofy about this. This is legitimately a dinosaur, but yeah.
If you're like me, it's probably Brontosaurus, Triceratops, or T-Rex. Doesn't matter that now I know better.
Those are terrible illustrations, by the way. Just really bad. Ugh. These, like, stock image websites are awful. Ugh.
No amount of scientific training could make me unsee the land before time. But Littlefoot wasn't the beginning of our cultural love affair with Brontosaurus. Everyone's favorite dinosaur that wasn't, Brontosaurus excelsus.
That's not even a diplodocid. This is supposed to be a titanosaur, like Saltosaurus or something. This is from Dinosaur Planet in, like, 2004, something like that. So they got this part wrong. Oh, boy. This is why you need to, like, consult scientists when you're making a science video for a wide audience. Because, like, just get basic stuff wrong.
Thundered onto the scene in 1879 when paleontologist Othniel Charles Marsh published a paper titled Notice of New Jurassic Reptiles. And Brontosaurus, basically due to an excellent PR team, quickly became the pattern card for our idea of these giant lizards.
They're not lizards. They're not lizards. Oh, boy. You know, we paleontologists are not, we don't ask for much, you know? For the price of, like, you know, a couple beers or something like that, I'm sure you could get a graduate student or even an undergrad in paleontology to look over your script real quick and correct some things that are just grievously wrong. We might even do it completely for free, just out of the goodness of our own hearts, you know, because we're tired of banging our heads against our desks when you've got lousy stuff like this, you know? Whatever.
But Marsh had discovered many similar fossils, and Brontosaurus's problems began around 1903 when a more in-depth analysis of Marsh's collection by another
Sudasukian. Yeah, Ken, remember that?
Differences
Oh, boy.
between Brontosaurus and the earlier named Apatosaurus were too slight for the two to be more than different species. Remember the biological taxonomy, kingdom, phylum, class, order, family,
genus, species,
well,
yeah.
Apatosaurus
Let's protect
became
our
the
fossils, because
And
if they're removed, America loses them forever.
CM Karlov, thank you very, very much for your support. I really appreciate that. Welcome to the community. Thanks for that that new recurring subscription. I appreciate that tremendously. Thank you very, very much. That's beautiful. Welcome, welcome. Play.
Common genus, and what we know as the Brontosaurus was demoted to Apatosaurus excelsius. But the name Brontosaurus refused to fade into the mists. It was so beloved, it took more than 50 years for
It's a great name.
consistently present the dinosaur under its correct classification. And the use of the name in pop culture and children's books persisted almost until present day. You know, because science literacy is not really a thing in this country. Speaking of museums, you may have heard a rumor.
She's right about that. Amen. Yeah. But anywho, yeah.
Rumor that the existence of Brontosaurus was
It is ironic, isn't it?
mistaken identity when a Camarasaurus head was incorrectly matched to an Apatosaurus body. But this isn't really true. Yes, at one time we thought the Apatosaurus skull looked similar to Camarasaurus's, but identification of Brontosaurus as a genus had nothing to do with that mix and match.
There we go. Yeah, shoot. This is why I was frustrated with Betsy's video there, is because she was conflating the two, or whoever wrote that script. It might not have been her. Yeah. So that, yeah, anyway. Yeah. Kind of embarrassing that D News got it better than the dinosaurs course at the University of Alberta, but whatever.
In fact, we didn't know what the skull of Apatosaurus looked like until the late 70s, when a fossil discovered in the early 1900s was finally confirmed to belong to Apatosaurus.
It was Jack McIntosh's work.
We're finally accepting that Brontosaurus was a thing of the past, and the name Brontosaurus is now returned. Well, this is how science works. It's a process, and new technologies and insights can render previous ways of thinking obsolete.
True.
Also, when it comes to naming really old organisms, scientists are constantly refining their approach. So in this case, an international team of scientists performed one of the most extensive specimen-based phylogenetic analyses.
Yep, this is the Emmanuel Shop paper I was talking about.
Specimens were scored for 477 morphological characters. The paper, published in the journal PeerJ, contains a provocative statement.
Yeah, there we go. Emmanuel Shop. Why did it get blurry?
Characters.
Hello, I'm
the paper,
Sam Neill
published
from
in the journal
Jurassic
PeerJ.
Park.
Hi, Sam Neill from Jurassic
Check
Park.
our fossils, because if they're removed, America loses them forever.
Burgers Girl, thank you for the follow, and welcome to Paleontologizing. It's good to have you here. Thanks for clicking that follow button.
J contains a provocative statement. Of particular note is that the famous genus Brontosaurus is considered valid by our quantitative approach. Now, this issue is by no means settled. Other researchers in the field have to agree, and that hasn't happened yet. One of the most important aspects of science is reproducibility. If your colleagues can't reproduce your experiment and results and draw the same conclusion as you did, your finding remains just an opinion, and that's not very scientific. But we have hope. And while experts like my friend Brian Swiddick warn that our old idea of Brontosaurus as a large, dumb, water-loving animal will never again see the light of day, a lighter, more streamlined version may once again take pride of place in our museum halls and textbooks. What do you think? Should Brontosaurus return? Subscribe to D News and let us know.
Yeah, or subscribe to Paleontologizing. Whatever suits your fancy. Anyway, does that kind of answer your question? If you go to Wikipedia right now, there is a legit article for Brontosaurus. Yeah. Let's see. The status of Brontosaurus is still uncertain, with some paleontologists still considering it a synonym of Apatosaurus. Yeah. Anyway, so science is constantly changing. Our views evolve with new fossil discoveries and new study of them. And so check back with me in 5 years, and we'll see if there's a newly formed consensus on the validity or invalidity of Brontosaurus. So yeah. That's part of being a science communicator like this, is that you gotta tell people sometimes, like, well, shoot, we don't know about this yet. And some people don't want to hear that. Some people just want a quick and easy answer. They just want to be able to Google something and go, oh, yep, well, that's the end of that. But science doesn't necessarily work that way. You know? When you're really trying to get to the truth of the matter, sometimes things are a little bit messy. Sometimes there's gray areas. Sometimes nature doesn't like to fit itself into these neat little boxes that we put it into. And that's the nature of science, since we're trying to figure out what's actually going on. Sometimes the narrative isn't as neat and tidy, you know? But that's the way the truth is. That's what makes it different from fiction. Anyway, yeah. And, Displacer says, have you ever heard of Pawpawsaurus? I saw it this summer. Pawpawsaurus. Yeah, Nodosaur from, the American South. It's found near where I grew up. Very cool, Displacer. Yeah, Jim Kirkland. One of my crew chiefs in the field. They don't really use the term crew chief on those crews, but whatever. I was working with Jim. Jim he's got a Pawpawsaurus skull cast, I believe, in his office. I think it was Pawpawsaurus. Let's look it up. But Jim works on ankylosaurs, and I think, yeah, no, it totally was, wasn't it? Yeah, there's the skull of Pawpawsaurus. Very nice. And hang on a minute. Digimorph. Could I print this? Oh boy. CT scan. I might be able to print the skull of Pawpawsaurus.
Digging up dinosaurs is hard, frustrating work. It takes months or years, so leave it to the professionals.
Thank you for the follow there, Orbit. Appreciate that. Welcome to the channel. It's good to have you here. Pawpawsaurus would probably look something like this. It's what we call a nodosaurid ankylosaur. So it's an ankylosaur that didn't have a tail club. Pretty cool armored dinosaur. Pawpawsaurus did not look like this. That's completely wrong. That's like a tyrannosaur. Anyway, yeah. That's a pretty decent Pawpawsaurus there. I like it a lot. Anyway, could I 3D print that one? Downloads. Oh boy, that's over a gigabyte. Yowza, yowza. What file type is this? Oh, that's just a million TIFF files. Ooh boy. I don't know if I could print that. But if I get in contact with folks from that project, I might be able to do that. That would be really cool. Yeah. Huh. Convert CT data to OBJ. How to convert medical scan data into 3D printable model. Also dinosaurs. Dinosaurs are not one of my search terms there, but holy cow. Oh boy. I might have to do that and print myself a Pawpawsaurus skull. Holy cow, would that be cool. Yeah. Get the software. There we go. Mesh Lab. I think I've used Mesh Lab before.
He'll tell you that in nature.
And Gamer Dylan, thank you for the follow. Welcome to Paleontologizing. Good to have you here. Yeah. Excellent. Good stuff. Yeah. And, oh, Chippermonk says, may I ask, it looks like the skull has ridges or bumps on the nose. Is that from erosion on the bone? No, that's part of the morphology of the skull of this animal. So a lot of ankylosaurs have got these bumps and ridges on their skulls, this cranial ornamentation. And that's actually one of the easiest ways to tell them apart from one another, is those bumps and ridges evolve really quickly, it seems. They may have been used in display. But yeah, oh man, that is lovely. Holy cow. Yeah, so those data are out there, and if I can convert them into printable form, I will be happy to do that. Holy cow, would that be cool? Oh, yeah. Yeah. But where does the name Pawpawsaurus come from, you might be wondering? Let's talk about it. I think it's named after the fruit. There. It means pawpaw lizard. From Tarrant County, Texas. Discovered in May of 1992. Oh, it's from the Marine Pawpaw Formation. That's interesting. I didn't realize it's another one of these land-living armored dinosaurs, one of these ankylosaurs that got washed out to sea and then preserved in ocean-bottom sediments, which is kind of wild. Yeah. This happened quite a few times, it seems. We call that bloat and float. And, here we go. Let's try this.
In 2011, a worker at an oil sands mine in Alberta.
This happens a lot, actually.
One of the most exciting dinosaur discoveries of the 21st century. While digging up the cliffside, the worker's excavator struck an unusually hard object, peppered with large tan splotches. He had just discovered
oh, wait, hang on.
the remains of a
That's an optivisor. Right there. This is what Don uses in the field. The optivisor. Holy cow, I've never seen somebody else use one of those. Some of you remember Don putting this on to look at stuff in the field. Yeah, and there it is.
Of a 110 million-year-old nodosaur. Nodosaurs were a group of armored plant-eating dinosaurs that lived during the late Jurassic and Cretaceous periods. And paleontologists have been studying these dinosaurs since the 1830s, but nobody had ever found a specimen like this one.
She does eyebrows. Oh, cool, Lenina.
At the Royal Tyrrell Museum named it Borealopelta markmitchellii after the technician who spent over 5 years cleaning up the fossil. It represented a
and reassembling it because they exploded it in the field by mistake.
Although the dinosaur's tail and a few other parts were missing, everything that was left was amazingly detailed. There was gorgeous.
Anyway, we've seen this, but let's get to the bloat and float part, shall we? Yeah.
Got there. Because the strange thing is, it was found lying on its back in a marine deposit. In other words, it was fossilized upside down underwater.
Yep, and this has happened many, many times with this kind of dinosaur. With ankylosaurs in particular, for whatever reason, we often find them on their backs on the bottom of the ocean, like in ocean bottom sediments. That's Borealopelta, that's Pawpawsaurus, that's Aletopelta from here in California, that's Niobrarasaurus from Kansas or Nebraska, something like that. For whatever reason, these poor dinosaurs kept getting washed out to sea and then buried upside down. Maybe they really liked to cross rivers, but were really bad at swimming. Maybe they're just really top heavy. I don't know. I don't know. Is Minmi also from, I thought Minmi was from terrestrial strata, Dinosaur Dave. Yeah, I don't know.
And a lot of other nodosaur fossils have turned up
Dead ankylosaurs, nature's canoe. There you go, Ken.
in similar deposits
left
behind by ancient waters. So
Yep.
how did these dinosaurs end up getting buried at sea? The answer to this question is a gross but also kind of cool process of decomposition called, wait for it, bloat and float.
Yep. Yeah.
Nodosaurs belong to a larger group of herbivorous dinosaurs called ankylosaurs. Scientists have found their remains on most of the world's continents, including Antarctica. And they generally divide ankylosaurs into two major groups, the ankylosaurids and the nodosaurids.
Yeah, although, talking with Jim Kirkland this summer, he thinks that there should be a third group in here too, which may be a subset of Nodosauridae. Or he thinks maybe Nodosauridae should be broken up into, it's not just a family. Anyway, Polacanthinae, or Polacanthidae, things like Gastonia, Polacanthus, Hylaeosaurus, etc., he thinks should be their own group. And he thinks Struthiosaurs, also, another kind of ankylosaur, should also be another group. That they're like all distinct from one another and they have, you know, internal affinities. Yeah, man, we gotta interview Jim on here at some point remotely.
Or the nodosaurs. The ankylosaurids tended to have short, wide skulls, and many sported bony clubs on their tails that were probably used as weapons. But nodosaurs didn't have these clubs. Instead, many of them, including Borealopelta, had long spikes on their shoulders and narrower snouts. Two of the oldest nodosaurs on record are Gargoylosaurus and Mimorapelta.
Yeah, and Mimorapelta. Who do you think that was named by, everybody? Not me. But Mimorapelta described by Jim Kirkland and Ken Carpenter in 1994. Yeah. It's really funny because Jim talks about Mimorapelta a lot because it's one of his dinosaurs, but the way that he says it, sometimes when there's a new volunteer on the crew, Jim will be talking about, oh, you know, and then that's where I found Mimorapelta. And they're like, wait, you found your Morapelta? Wait, what?
Let's protect the fossils.
The dinosaur's name is Mimorapelta.
America loses them forever.
And NYC East 34 Ferry, thank you for that Prime sub. I appreciate that very, very much. Thank you kindly. That is wonderful. Anyway, Jim's not being really possessive of this dinosaur. It's just named Mimorapelta. But yeah, and there it is right there.
Both were around 3 meters long and lived in the western U.S. during the late Jurassic period. But nodosaurs persisted throughout the Cretaceous period, sticking around right until the age of dinosaurs ended.
Very successful group.
Ago. And both nodosaurs and ankylosaurids often turn up in marine fossil deposits.
Yeah.
Now, you might remember from our video when sharks swam the Great Plains that from about 95 to 68
Three historic horrors. What's all this archaic anatomy in aid of?
Dr. Geekosaurus, it sounds like you're in the right place. Welcome to Paleontologizing. It's good to have you here. Thanks for following.
When sharks swam the Great Plains, that from about 95 to 68 million years ago, a huge body of water called the Western Interior.
And thank you, Ross Scully, for following also. Welcome to the channel. It's good to have you here. Welcome. Thanks for following.
Anyway, split North America. And earlier in the Cretaceous, much of west central Canada and the upper Great Plains were covered by the Maori Sea, an extension of the Arctic Ocean. So there was a lot of available sea for the armored dinosaurs to end up in. For example, take the
Lots of
nodosaur
accommodational
known
space.
as Niobrarasaurus.
I mentioned this one a few minutes ago,
Cretaceous marine deposits of western
Kansas. There we go.
Some of its fossils even bear the tooth marks of ancient sharks. And lots of other armored ankylosaurs, including nodosaurs, have been...
And hang on a moment. Ross Scully here says, big fan. Just got back from a month of touring European museums, including the Paleo Centers of Scotland. Very cool. Did you get to see Djark, the new pterosaur at the University of Edinburgh? Or Edinburgh Museum?
Loses them forever.
And holy cow, I appreciate that Prime sub Zenfail. Thank you very, very much for that. Welcome. For anybody who's new here, allow me to introduce myself real quick. My name is Danny Anduza. I'm a dinosaur paleontologist. And I just got back from about 2 months worth of field work in Wyoming and Utah digging up Cretaceous dinosaurs. And now I'm back in my office. We're going to be going over some new dinosaur genera that were described while I was out in the field that we couldn't talk about because I was out digging up new dinosaurs. But yeah, we'll get into that in just a little bit. But right now we're talking about bloat and float ankylosaurs because a question came up about ankylosaurs and we kind of got off on into a little rabbit hole here. But anyway, it's great to have you here. Let me know if you got any questions. Yeah. And Professor Dave says, do you know of this, if this is what happened to the Nodosaurus in the Tyrrell Museum that's fossilized? That's what this video is about, Professor Dave. That's Borealopelta. It's a type of Nodosaur. Here, what are we at here? We're at 352. There we go.
Parts were missing. Everything
Yeah.
that was left was amazingly
That's it.
detailed. There was a gorgeous skull, articulated neck vertebrae, several leg and foot bones, and portions of the torso and hip
That's the one.
regions. But it was the rest of the fossil that made international headlines. From the hips forward, Borealopelta had an almost complete set of osteoderms. Osteoderms are
Gorgeous.
bony plates that are embedded
Yeah.
in the skin, just like what alligators have today. Nodosaurs and many of their relatives had back.
Anyway, and Miss Yvette, thank you for the 300 bits. That really is lovely. I appreciate it. And you've just kicked off a hype train here. Fantastic. I appreciate that, Miss Yvette. Thank you, thank you. Anyway, yeah, this was the one that was dug up.
While digging up a cliffside, the workers' excavator struck an
at the Tyrrell
unusually
Museum.
found object. Remains of a studying the
Yeah, anyway, let's go to 352 where we were.
Better yet, Borealopelta contained super rare remnants of softer body materials and even had traces of pigmentation,
Yep.
giving us important clues about the animal's color pattern. And the Nodosaurs
Pretty cool stuff.
have been found in marine deposits.
Oh, Kunbarasaurus. There you go, Dinosaur Dave. You were correct about that. Kunbarasaurus is from marine deposits also. Says, we're watching this video because of the bloat and float, thing. Like, why is it that ankylosaurs are just, they were constantly floating out to sea and getting buried in marine sediments?
Armored ankylosaurs, including nodosaurs, have been found in marine deposits from places like Queensland, Australia, and James Ross Island, Antarctica. One species was even found in California with oysters encrusting on its
Aletopelta.
And then we have Borealopelta, the spectacular nodosaur that those Albertan miners came across. Its remains were discovered in the early Cretaceous Clearwater Formation, where the fossils of marine reptiles like plesiosaurs and ichthyosaurs often turn up, but scientists had never found any.
I kind of doubt they found ichthyosaurs in that formation because that's what, from the late Cretaceous? I think ichthyosaurs were extinct at that point. Ichthyosaurs go out in the middle Cretaceous extinction, I want to say. So that might be a goof on their part, or you might have a super late surviving ichthyosaur that I'm not aware of.
Dinosaur material out there until Borealopelta. So what happened? Well, after its death, Borealopelta's corpse hit the sea floor around 200 to 400 kilometers away from the closest shoreline. And it landed upside down, which turns out to have been a common fate for nodosaurs. Computer simulations suggest that these top-heavy animals would have flipped over pretty easily while floating in the water. So below the waves, Borealopelta came to rest in a layer of stagnant, oxygen-poor mud. Traces of burrowing sea creatures were found nearby, but paleontologists found no evidence that the dinosaur's body was scavenged. And when it was discovered, Borealopelta was encased in a tomb of hard rock called a concretion.
So hang on a minute. If there's no evidence that the skeleton was, that the carcass was scavenged, then what happened to the back half of it? Was that destroyed by the mining equipment? So we would otherwise would have had an 100% complete nodosaur? Huh. I mean, we're lucky to have this thing at all. Don't get it twisted. Don't think I'm complaining about this. But, yeah. Huh.
As its body decayed, carbon dioxide and other substances were released, which changed the chemistry of the water inside the mud around the carcass. Soon enough, a tough layer of siderite, a type of iron carbonate, formed, protecting the dinosaur's remains. But how did it get so far away from the coastline? After all, Borealopelta was heavily armored and short-legged, so it was probably a terrible swimmer, and it lived on land anyway, so there's no reason to think that the nodosaur swam to its watery grave. It's more likely that the dinosaur's body was washed out to sea. Sometimes after an animal dies and bacteria start breaking it down, gases build up inside the corpse. And if the carcass ends up in a body of water while that's happening, it might start bobbing around at the surface. Scientists call this phenomenon bloat and float. Eventually, those gases escape, the body stops floating, and it sinks to the bottom. And no matter where an animal dies, there's a good chance its remains will get scattered around after death. But the concretion around Borriella pelta kept most of its skeleton together. Better yet, the rocky shell helped the dinosaur retain its three-dimensional shape, even as layers of sediment piled up on the carcass over time. Between the bloat and float process and the seafloor environment where it landed, Borriella pelta kind of hit the jackpot in terms of preservation. For example, along with those osteoderms, experts found that the fossil was also covered with tiny polygonal scales on much of its skin, and delicate skin structures were spread out across the skull, neck, back, hips, and even its legs. Plus, many of the dinosaur's osteoderms, along with other parts of the body, were coated in a dark gray material. This stuff has been identified as a kind of organic film, and it's loaded with the chemical traces and byproducts of keratin. Keratin is a key ingredient in fingernails, hooves, feathers, and hair, and some modern reptiles, like alligators, have keratin sheaths over their osteoderms. Unfortunately,
their armor
keratin
plates.
often vanishes without a trace during the fossilization process. But the organic film on Borriella pelta preserved the original three-dimensional structure of the keratin sheath.
Pretty awesome.
And lengthened the
That's
bony
kind of
structure
extraordinary.
when the dinosaur was alive. The ones on Borriella pelta's shoulder spikes are a centimeter thick in some places and make up about 25% of the total length of each spike.
Which is really, really cool, because normally we only have the bony core of these things. But to have the keratin sheath partly preserved gives us an idea for how long those spines would have been in life. Just super, super cool.
So this gives us a clearer picture of what the nodosaur actually looked like. But wait, there's more. The film of keratin wasn't even the most spectacular aspect of this fossil. This dinosaur had preserved evidence of coloration, and it came in an unexpected pattern. Some of Borriella pelta's scales bear the chemical hallmarks of a pigment called pheomelanin. Judging by these traces, it appears that most of the dinosaur's back was a reddish brown while its underside was pale. This means that Borriella pelta could have been countershaded, or darker on its upper side and lighter on its underside. Countershading can make animals much harder to see because of the way shadows help us perceive objects. When sunlight hits a three-dimensional body, it tends to look light on top and dark on bottom. So if these creatures are lit from above, they'll look almost uniform in color. Their dark backs will be illuminated and their light underbellies will look darker. Because of that, predators might not even recognize countershaded animals as three-dimensional objects. Visually, they're harder to make out. This would have been really useful for Borriella pelta because even though it was really big, like 1,300 kilograms, back in the nodosaur's heyday, massive carnivores stalked North America.
Like
And one of them was
Acrocanthosaurus,
Acrocanthosaurus, a predator that measured 11 meters long and could have weighed a little over 7 metric tons. With enemies like that on the prowl, Borriella pelta may have benefited from a little camouflage. Without the amazing preservational environment created by the concretion and the whole bloat and float thing in the first place, we wouldn't have any clue what color this huge dinosaur was or what it ate. And that brings us to a soccer ball-sized lump found in Borriella pelta's abdominal cavity. In 2020, Royal Tyrrell paleontologist Caleb Brown and his colleagues recognized
This is a great video.
as a cololite, which is a hunk of fossilized intestinal contents. Even though Borriella pelta had ended up in a marine deposit, this cololite was loaded with bits and pieces of land plants. Fossil sites in other parts of Canada tell us that central Alberta was home to a wide variety of terrestrial plants in the early Cretaceous.
Yeah, I think it was mostly eating ferns, wasn't it? Something like that. If I remember this correctly, let's continue.
With conifer forests dominating the landscape. But it doesn't look like Borriella pelta was too keen on conifers. Leaf tissue makes up 88% of all the plant material that was identified inside the cololite, and the vast majority of those leaves came from ferns.
Yep, ferns, like I was saying. Although I think they also found charcoal in that cololite also, showing that it was like chewing on some charcoal. And that's kind of unusual because, I don't know, this is the thing. Anytime that you're trying to figure out a dinosaur's diet based on what was preserved in its guts, well, you know, it definitely ate those things. If it's there preserved, well, it probably ate those things, unless the stuff got washed into its ribcage afterward. It probably ate those things, sure. But if that's its last meal before it died, is that really what it was eating all the time? Or could that be something that it ate while under stress? During a drought, during a famine, maybe it's something it didn't agree with it. Maybe that's why it died. Gut contents are not always a perfect indicator of diet in extinct animals and fossils like this. Shoot, yesterday we talked about this. Yeah, with a Xiphactinus anglicus. So this is that famous fish within a fish fossil. It's got this big Xiphactinus, and it ate this Gillicus, and then it died immediately afterward. It may have actually choked to death on this other fish, like you see here. And that might be what actually killed it. So yeah, gut contents are not always the best indicator of what an animal's normal diet was. Because the fact that it died immediately afterward might not be the best sign for that kind of thing. Does that make sense?
Which is interesting, because scientists had always assumed that nodosaurs with their long, narrow snouts were picky eaters. Instead of chowing down on a mixed foliage indiscriminately, the dinosaurs would have carefully plucked their favorite plants. And Boreal
makes sense for a nodosaur,
look like evidence of this. But they also point to something surprising about the environment that it lived in.
The charcoal, right?
Inside the cololite, the researchers discovered a few samples of charcoal that the dinosaur apparently swallowed. In fact, burned plant fragments represent 6% of the botanical material in the cololite, and perhaps that says something about Borealia pelta's feeding behavior. Researchers think wildfires were quite common during the Cretaceous. When Borealia pelta was alive,
HD says, I told you it shouldn't have gone swimming after eating.
oxygen may have made up around 30% of Earth's atmosphere, compared to just 21% today. And when these natural disasters happen,
So this would have been at this point in the late Cretaceous. Oxygen levels fluctuated throughout the age of dinosaurs. I don't want anybody to get the idea that, like, oh, dinosaurs were able to get big because there was 900% more oxygen at the time. No, that's not true at all. But during this period, I think this is the Campanian that, anyway, the Campanian stage is actually really long in the Cretaceous. At this particular point, when Borealia pelta was alive, oxygen levels may have been a little bit higher, like, 20, 30% higher, something like that.
ferns often bounce back faster than other plants do. For a brief period, ferns may actually dominate a post-fire landscape as the environment recovers. So if Borealia pelta was a picky eater with a taste for ferns, then maybe the dinosaur was attracted to wildfire-stricken areas where these plants are thriving.
Because ferns are one of the first plants that bounces back after you have a big wildfire. We call that like a disaster flora. If there's a big wildfire or a landslide or something else that just kills all the plants in the area, oftentimes ferns, which reproduce via spores, ferns are one of the first things to come back after that. So like when Mount St. Helens erupted back in, what was it, 1980? Let's see. Is it recovery flora? Is that what it's called? Flora. Where, yeah, let's see here. I don't know if I'm able to find it fast enough in a live broadcast. But yeah, ferns are often the first plants to come back after you have a big disaster like that where all the other plants get killed off. Ferns are very good at recolonizing environments. There we go. Yeah. So after the big asteroid impact that killed the non-bird dinosaurs, from the ashes of the impact, the first life to recolonize these areas were the ferns, known as the fern spore spike. This occurrence has been seen in smaller scale extinction events like 1980 Mount St. Helens eruption, where fern species recovered much more quickly than other organisms. Amazingly, the resiliency of ferns has never been thoroughly investigated until now. Very cool. So here's an article about this if you want to read about it. Yeah. So it could very well be that this Boreala pelta was ingesting some charcoal because it's just gobbling up all these ferns in fire-stricken areas. I think that's what she mentions here in the narration, right?
Atmosphere compared to just 21% today. And when these natural disasters happen, ferns often bounce back faster than other plants do.
There you go.
For a brief period, ferns may actually dominate a post-fire landscape as the environment recovers. So,
and pioneer species, what's this, Rizudego? Oh, very cool. Oh, this is awesome. Thank you, Rizu. These plants go by many names, including pioneer species, first colonizers, early successional species, post-fire specialists, etc. Ferns and mosses are some of the first greenery we see after a fire. Yeah, first spring, next few years. But that's super cool. There you go. There's your ferns there. Beautiful. Thank you for sharing. That's super cool.
So if Boreala pelta was a picky eater with a taste for ferns, then maybe the dinosaur was attracted to wildfire-stricken areas where these plants were thriving. Between the remnants of keratin and its preserved dietary clues, Boreala pelta might be the most significant nodosaur fossil ever found. And just think, the dinosaur could have been lost to us forever if it hadn't bloated and floated across an inland sea. In death, this creature beat the odds, evading scavengers and the ravages of fossilization before it survived the mining process and caught
partly survived
the operator's eye. By doing all this, it's given us a bounty of dinosaurian knowledge. So here's to Boreala pelta markmitchellii, an improbable ambassador from the early Cretaceous.
Pretty cool indeed. That's pretty awesome, really. In fact, it'd be really neat to do a to sculpt and print and paint a Boreala pelta model, but I guess I don't really have to, because you can get Boreala pelta models like this.
Astonishing, simply astonishing. One of the most singular specimens I've encountered in
It is
all
a
my
singular
distinguished
specimen.
career. But enough about my work. What did you want to show me, Lisa?
The moon does exist.
And Eddie Money 2 and Jank Hill, thank you both for the follows. The moon does exist, and I'm happy that you followed, regardless of the moon's existence. Good to have you here. Yeah. So anyway, this is really, really cool. Beautiful model from PNSO. In fact, oh boy, this is available on the Amazon. I would not mind having this. That would be super, super cool. Let me add this to the wish list, just in case we have any super generous viewers who would like to purchase for me that. Because that's gorgeous. It really is. Holy cow. Yeah. Fantastic. But yeah. And Dinosaur Dave says, where I grew up, there was a sandy environment, and ferns loved it, yeah. Because sands are constantly shifting and changing, and so ferns are able to colonize that before other plants can get a root hold. After a fire, ferns would dominate for about 6 to 12 months until the eucalyptus could recover enough to shadow them out. There you go. Yeah, see, Dinosaur Dave knows what's up. Yeah. And, do I know anything about the Nodosaur voice box reconstruction? How did they do it? Baha, are you talking about the nasal passages or the larynx? Yeah. But yeah. And TGI Rex says, would you say it's easier to find the diet of a carnivore or herbivore, or would it depend on the circumstance? It depends on the circumstance, yeah. Like, to find out exactly what they were eating? It's often maybe a little bit easier to find with carnivores because you might find bite marks on the bones of their prey, and sometimes you can match up those bite marks with a particular carnivore. So, like, we have that for Tyrannosaurus, for instance. Yeah. So, this is pretty cool. This is research that was done by my old crew chief, Denver Fowler. And by studying, very carefully examining the bones of Triceratops, a bunch of different Triceratops specimens, he noticed some similar patterns in the bite marks that would appear on them. And there's a particular method by which these Tyrannosaurus, these T-Rex, were pulling the heads off and then eating the meat off of them. Yeah. So yeah. So that's pretty cool. It's often a little bit harder for plant-eating dinosaurs. But yeah. Arle, you definitely did know me before paleontologizing. That's my dad, everybody. Yeah. Arle, you are correct. Yeah. Anyway, TGI Rex is, I'm guessing for T-Rex, its natural prey would be Triceratops and Edmontosaurus, among others, yeah. I'm sure T-Rex would eat whatever it could get hold of. We have bite marks on Pachycephalosaurus from Tyrannosaurs. We have bite marks on other Tyrannosaurus from Tyrannosaurus. There was a display at Museum of the Rockies where I used to work talking about this. Oh, yeah. And they reconstructed the sound it made for an ankylosaur, really? I may have missed this. There we go. Yeah, shoot. This is from back in March. We covered this when it came out. I forgot. Fossilized ankylosaur voice box reveals that these beasts may have sported a far more sophisticated vocal range than scientists had originally thought. This is cool stuff. Yeah. Yeah, our study finds that the larynx of Pinacosaurus is kinetic and large, similar to birds that make a variety of sounds. Study first author Junki Yoshida, paleontologist at the Fukushima Museum in Japan, told Live Science. Yeah. Cool stuff. Yeah. Go away. It's really hard to even begin to infer what Pinacosaurus sounded like, because this is likely a novel vocal organ that produced its own kind of characteristic sound. James Napoli. I met James Napoli at the conference. In fact, I might interview him on this channel at some point. Vertebrate paleontologist at the North Carolina Museum of Natural Science was not involved with the study, told Life Science. Yeah. I agree with him on this. He says, I think chirpy birdsong is unlikely, despite functional similarities to a syrinx, just because of how large ankylosaurs were. In my head, I imagine low, reptile-y rumbles and grunts and roars with an intricate bird-song-like complexity. There you go. And so, in thinking about that, we can start to speculate about what these animals would have sounded like. Basically, you can take birds singing, take those recordings and just slow them down, make them lower frequency, and that might give you a pretty good idea as to what these animals, non-avian dinosaurs may have sounded like. Given they may have had similar vocal apparatus to birds.
It's got nothing to do with oil. I'm a paleontologist.
Miss Pilcrow, thank you for the follow. Welcome, welcome. Yeah. Yeah, okay. Let's try a nuthatch here. Yeah, some of them are really, really cool. Sedge warbler, stone chat, white throat. This is not the same video that we watched last time. Where was that? There we go. Birds sound like non-avian dinosaurs slowed down. There you go. Would it be slowed or just a lower tone? Same thing, Rizadego. Yeah. Lower frequency just basically means slower, which means deeper. Here. Let's try Indian peafowl. There you go. Mr. Corpse says, that woke my cat up. There you go, right? There's some deep ancestral, memories there in the mammalian psyche. Like, uh-oh, shoot. Better go hide. Yeah. Woke your cat up too, Reagan Nation? Try this one. These are legitimate dinosaur sounds made by modern dinosaurs. But you slow them down and they sound like Mesozoic dinosaurs. The ancient ones. There you go, Ken. Yeah. Yeah. What a loud place. Earth, a Cretaceous forest probably would have been a pretty noisy place. Yeah. That's so cool. I might sample some of these, actually, for some upcoming projects. Loons are very cool, Mia Miyakoto. They're very, very cool. And there's our brood hen. Oh, I love that. What a great video. Let me give you the link. This is good stuff. There's our bald eagle again. This one's not as impressive, I don't think. Let's try a European robin. That's not as impressive either, but let's try the starling one that Lenina has here. Very cool. Ah, that's so neat. I'm actually reading a book about starlings right now, which I've been really enjoying. And, ouch. Amazing. Yeah. Very, very cool stuff. So yeah. Feel like I'm being hunted, Siskin. Yeah, holy cow. You know, if birds like eagles were just a little bit larger, they probably would carry off small children with relative frequency. But yeah. It says, I wonder if some dinosaurs had the ability to mimic sound like some birds do. Well, those birds are dinosaurs. So maybe. I don't know. That sort of behavior doesn't fossilize well. So it's hard to say. But yeah. Golden eagles definitely would. There you go, Ken. Yeah. In fact, shoot, there is that... Was it the Tong child? Killed by eagle. There we go. Yeah. This was a really cool fossil of a human ancestor, the Tong child. The Tong child is thought to have been attacked and killed by an eagle. Scientists suspect an eagle killed the Tong child because puncture marks were found at the bottom of the 3-year-old's eye sockets. These marks resemble those made by a modern eagle's sharp talons and beak, where they attack monkeys in Africa today. Yeah. So anyway. Yeah. This little proto-human was probably killed and eaten by a dinosaur. So yeah. This was a not uncommon fate. In fact, I shouldn't be laughing about this, but it reminds me of one thing from this summer where, thanks for dropping in there, Ceratopsian Sam. It sounds like you're in the right place. Welcome to Paleontologizing. It's good to have you here. There we go. I remember this image came up for some reason when we were sitting around in camp one night, late in the field season. I think Fisher and Ethan were talking about this. And, yeah, and I'm like, oh yeah, I saw this same image once. And it had the caption, let me see if I can find you the caption. I can't, shoot. Anyway, the caption was, that feeling when you're the first one to fall asleep at the sleepover. But yeah. But yeah. That's my cat when I'm slow to feed her. There you go, Mr. Corb. Yeah. And Alex Vixen says birds will instinctively attack the eyes. It's why you're not supposed to have a parrot sit on your shoulder. I know it might explain why pirates tended to be missing an eye on the parrot's side. Is that right? Really? How many pirates really had parrots, though? But yeah. And Steely Den, I did not see the news about a huge dinosaur track site found in Alaska. That's interesting. That does tell me that I've been streaming now for 2.25 hours. Let's get back into what we were doing yesterday. Let's finish up our new dinosaurs from this summer. Pull that up. Yeah. So, there have been 9 new species and genera of dinosaurs described while I was away in the field this summer. And, we're going to talk about them. We went through 4 of them yesterday. We're going to do the last 5 today. So let's go ahead and get into that, shall we? Looking at the original publications wherever possible. We got through June yesterday, but we'll do a quick run through of our June ones. And we'll jump into July and then our one dinosaur from August too. So yeah, this is actually pretty reassuring. Hang on a minute. Well. Jack's Facts, thank you for the raid and welcome to Paleontologizing. How are things, Jack's Facts? How did the zoology go today? I hope it was excellent. If any of you are not yet following Jack's Facts, Jack works on animals and is all about the facts. Follow him. Anyway, I'm glad to be back from the field, Jack's Facts. And we're actually about to go over some of the dinosaurs that I missed. Normally we go over fossil news pretty much as soon as it's published. But I was out digging up my own dinosaurs this summer and didn't have the wherewithal to really talk about new discoveries very much. So we're catching up on those right now. So you came in at the perfect time. We're just getting into this. Yeah. Anyway, good stuff. June yesterday. Well, yesterday we went over June. McManny-Kion talked about this critter, Basal Maniraptoran. Although it's based on scanty materials, so it very well could be something else. I don't know. We'll see. We had Eoni, a little speedo, a small-bodied early diverging ornithischian from Utah, discovered, dug up, and published on by Lindsay Zano's crew from North Carolina. Really exciting dinosaur. We've got Vectipelta from the Isle of Wight, published on June 15th. And Gonkoken is what we finished on yesterday. Published on June 16th in the late Cretaceous. A non-hadrosaurid hadrosauroid. So we talked about what that meant. And, cool critter. So now, let's go ahead and get into July, shall we? In July, I was about to leave for fieldwork in Utah. And I think, yeah, there we go. Minimo Cursor is our very first one. And with a name like that, Minimo Cursor, does anybody have any ideas as to what kind of dinosaur this might be? Minimo Cursor. Any clues at all? What does that tell you about the animal, just based on its name? A small arrow? Small? Small hands? Flat? Mini? Small dinosaur. You're not wrong about that. Yeah. Cute? It cursed a lot? Does it use a mouse? It's small and fast? Sounds like a Windows option. He swears just a little bit? Oh, cursor. Okay, I get it. In, you know, in Latin, cursor means like cursorial. It means like running. So it means like the very small runner. So yeah, and it is a neornithischian. Tyrannosauro dos. Claro que sí. Yeah. So like coursing, there you go. Yeah, yeah. And cursor is where you get courier from. That makes a lot of sense, Espy. I've never thought about it that way, so that does make sense. Yeah. But this is the little beaky plant-eating dinosaur. There we go. And here is a beautiful life reconstruction of it. Look at that. Just very, very petable. Yeah. Probably make a pretty decent pet. Minimo Cursor. Minimo Cursor Funoyensis. Anybody have any guesses where this dinosaur might be from? Based on that species name? Funoyensis. Ensis means from that place, but what does Funo mean? Does that sound like anything to anybody? And thank you, Tony is my baby, for the follow. Welcome to Paleontologizing. Yeah. And Thailand. Ding, 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 Alex Vixen. Yes, indeed. It's from Thailand, published on July 13th. I was getting ready to do my fieldwork in Utah at the time. And it is from the late Jurassic, age uncertain, I guess. Exact age uncertain. Of Mukdahan province in Thailand. We don't have too many dinosaurs from Thailand yet. So, that's pretty exciting. It is. Yeah. And it's another Speedo, a small-bodied, early diverging ornithischian. Less than a meter long. This is a small dinosaur. So depending on how big your screen is right now that you're watching me on, this dinosaur may be more or less life-size. It's less than 3 feet long. I think they've got several individuals that have, or maybe it's one. Holotype was excavated in 2012. Yeah. Sometimes people ask me, Danny, how long does it take between the excavation of a dinosaur and then when the dinosaur actually gets published and announced to the public? This is about average. It's about a decade. Give or take a few years, you know? And do we have histo? I don't know if we do, Claire Burr. That's a great question. We'll look at the paper. But it is known from several specimens comprising about 50% of a skeleton when you put them together. So that's pretty decent, actually. This isn't one of those dinosaurs based on a single element. This is, yeah. This is much better than that. And this is not related to Compsognathus or other small theropod dinosaurs. This is a beaky plant-eating dinosaur, what we call an ornithopod. Yeah. And it's one of the few dinosaurs known from Thailand. Let's take a look at that paper, shall we? Yeah. Give me a second here and let me pull that up. Should be right in here. Minimo cursor. Yeah, open access paper. A new basal Neornithischian dinosaur from the Phu Kradung Formation, Upper Jurassic of northeastern Thailand. Apologies if I've butchered that. I do not speak Thai. But really, really cool to have a new dinosaur from Thailand. So an exceptional articulated skeleton of a new basal Neornithischian dinosaur, Minimo cursor funoyensis, new genus, new species, was discovered in late Jurassic Phu Kradung Formation of the Phu Noi locality, Kalasian province, Thailand. Very, very cool. Let's take a look at some of the photos they've got. Oh, this is where it's from in Thailand. There we go. And holy moly, they've got like a whole bone bed there of different critters. That's super, super cool. Oh boy. Photograph of the excavation site in 2023. Very nice. That's super exciting. Yeah. So we've got one partially articulated specimen, a left foot with a tibia, and an isolated lower jaw. Very nice. Yeah. Specimen's more than 50% complete. Well-preserved articulated series of vertebrae with ossified tendons. Those are like ligaments in the animal's tail, mostly, that actually turn to bone as the animal ages. It's super cool. A lot of ornithischian dinosaurs do this. Left scapula with some parts of the coracoid, the entire pelvic girdle, So we got all the hips. Left femur, tibia, and fibula, left tarsals, metatarsals. Some displaced bones include the right jugal, the left syringular and angular, those are skull bones, and the left manus, the hand. Right femur, tibia, and fibula, phalanx, ungula, and ribs. Very nice. So the specimen is now in the fossil collections of Mahasarkham University in Thailand. Beautiful. And look at that. Gorgeous slab right here. When we say inarticulation, that's what this means. I mean, this is just absolutely gorgeous. Look at that right there. You've got those dorsal vertebrae all in place, leading to the hips. You've got a femur. In the lower leg there, tibia, fibula, metatarsals. And then you've got the tail extending off of it. Just gorgeous. Really, really beautiful. And chances are they're going to have much more of this animal in the future. Take a look at that. That's extraordinary. I didn't know they had fossils this beautiful from Thailand. This is really exciting. Something to be proud of. That's... Oh boy. This animal better show up on some commemorative stamps or something in Thailand, because that's gorgeous. Very nice. Yeah. There's an actual photograph with no UV distortion or anything. Really, really nice. Yeah. Lovely. Super cool. And there's a reconstruction of the skeleton. The bones in white are the ones that are represented there. So a decent part of the skeleton. Really, really lovely. And there's a reconstruction of what the animal may have looked like in life. Again, a speedo, a small-bodied, early diverging ornithischian. One of these little, fast, two-legged, beaky, plant-eating dinosaurs. Lovely. Yeah. And Espy says, how would this happen? Did the dinosaur get buried alive? Maybe. Yeah. It's just beautiful preservation, you know? I guess you didn't have... It obviously didn't get swallowed whole by a theropod or anything. You know? Yeah. And there are the skull bones. The skull is largely based on Hypsilophodon right here. Good stuff. Very cool. And there it is under UV. Just, exquisite preservation. Very, very nice. Lovely. I could look at these figures all day. Yeah. Look at that scap right there. The shoulder blade. Really nice. And there's the hand. In articulation. Right there. The bones still together as they were in life. Very cool. Yeah. And there are the hips. Ilium, pubis, ischium, and then posterior pubis here. Very nice. Just beautiful. Holy cow. What a cool critter. What a beautiful, beautiful paper. There's a representation of what this ancient ecosystem would have been like. So every critter that you see here, including the plants also, I guess, there are fossils from this fauna. We've got a crocodilian here. We've got hybodont sharks, lungfish, turtles, amphibians, bony fishes. And here's our little guy, Minimo cursor. There's big sauropod dinosaurs in this environment, big theropods, and a stegosaur too. Pretty cool. It's neat how just from bits and pieces of different critters, even if we can't name them, we still know that that kind of dinosaur was there in this environment. It kind of gives us a sample platter of like what this ecosystem was like, who were its inhabitants, what's the cast of characters. Really nice. Yeah, I love that they included that in here. And it's color-coded too. Beautiful. Yeah. Nice. So yeah, good stuff. I am so excited to see what else comes out of this locality in the future. But, for right now, we've got a beautiful new dinosaur from right there in Thailand. Very, very cool. Yeah. And is it common for fossils to fluoresce? It kind of is, Murph, yeah. Certain fossils, depending on the minerals that make them up, will fluoresce or at least be more visible under a black light or other kinds of lighting like that. Yeah. Good stuff. Yeah. And Baha says, did I hear somewhere that fossils usually are slightly radioactive? Not usually, but in some circumstances they are. Yeah. It depends. It depends if there were radioactive materials that went into the fossilization process, you know? So like in the Morrison Formation, the late Jurassic of North America, there are a bunch of fossils that are radioactive. Some of them are like... There have been dinosaur fossils found in uranium mines before, and those are radioactive enough to where you can't work on them. It's not safe. Actually, just a few miles from where I was working this summer in Utah were a bunch of uranium mines where dinosaur bones, some of them were actually ground up and used as fuel in like nuclear submarines and stuff like that. So yeah. You would just have piles of dinosaur bones stacked up outside these uranium mines, and some of them were used as fuel. So yeah. But yeah. And Gojira says everything is slightly radioactive. I mean, above background levels, Gojira. Yeah. But most fossils are not radioactive. It's interesting when they are, because it's out of the ordinary.
Of lifestyles of the large and extinct.
And thank you, Bassmitho. I appreciate that follow. Welcome. Yeah. Baha says, I hope my bones get used in reactors someday. Well, what do they say? Shoot for the moon, and if you miss, you'll just be drifting endlessly in the vast emptiness of outer space for all eternity. Yeah. Anyway. Let's get back to our presentation here. So, welcome to the world. Beautiful Minimocursor Phonoyensis. Published on July 13th. Let's see what's next. Yeah, Obletosaurus is next. And I'm excited about this one because I actually emailed the authors of the paper. And it's not an open access paper, but I happened to get a copy from the authors, which is pretty cool. Yeah. So let's get into that, shall we? Obletosaurus is next. Let's take a look. And there we go. Another ornithopod. Obletosaurus. Obletosaurus bunueli. So this is a dinosaur that's probably not too different from the dinosaurs that I was digging up this past summer in the Cedar Mountain Formation of Utah. It seems like our iguanodontians have got some camptosaur affinities, and this is like a Camptosaurus type dinosaur from Europe. Yeah. Published on July 18th. That's actually the day I left for the field with Don DeBlue and Ethan and the rest of the crew. And it's from the late Jurassic to possibly early Cretaceous of eastern Spain. So the Iberian Peninsula, Spain and Portugal, are kind of an exciting new frontier in dinosaur paleontology right now. There's so many cool Jurassic dinosaurs that are coming out of those countries, and this is just one of them. Really exciting stuff. So it's closely allied with Camptosaurs, like Camptosaurus, if you're familiar with that dinosaur. I actually have a Camptosaurus hand. Let me go grab that. Here we go. Yeah. This is a hand of Camptosaurus right here. And this is life-size. Camptosaurus got a lot bigger than this, but this is like a medium to smallish Camptosaurus from the Morrison Formation. And just like us, it's got 5 fingers. Thumb, index finger, middle finger, ring finger, pinky finger. So tetrapod animals, once they come up out of the water, they've got 5 fingers ancestrally. And, yeah, so like this is a right hand right here. And so this is maybe thinking about starting to develop into that thumb spike that you have in iguanodonts later on. But, it's not there yet, you know? So yeah. Anyway, Camptosaurus, it basically looks a lot like this critter right here. So you can see that similarity with that hand. Yeah. And these little hands right here. Yeah. And this animal, I don't think it's super large. I want to say it's 3 or 4 meters long, something like that. So, you know, about the size of a compact car, maybe. Yeah. How often do I high-five this? Not often enough, random man. Yeah. But yeah. Let's see. It's known from a nearly complete hind limb, plus a tooth and a claw. And so this is not a dinosaur that we have a complete skeleton of, but from the hind limb there, from those back legs, and the tooth and the claw, we can tell it's definitely a Camptosaur. But there's something very cool. The fact that there is a hind limb from this animal allows for some pretty neat science. It may actually be responsible for some footprints that are found in the region from the same time. And so this might be one of those instances where you can actually match up a particular dinosaur's bones to a particular dinosaur's footprints, which is pretty rare to be able to do that. So that's really cool. Yeah. And it could be related to our new iguanodontian in Utah, the one that I was digging up at Doling's Bowl with Jim and Don and Ethan. So let's take a look at that paper, shall we? Yeah. Obletosaurus. Where did I put that? I got the paper. Did I not? Oh, there it is. Yeah. So the lead author on this, Sergio Sanchez Fenollosa, was kind enough to send me a PDF of this paper because unfortunately, it's not open access. But yeah, I don't know. He was super cool about it. I told him that we were digging up some new iguanodontians in the Cedar Mountain, might have affinities with this, and he's like, "Oh, very cool." Yeah. So yeah, let's take a look. There is where it's from in Spain, so east of Madrid, in the South Iberian Basin, and it seems to be right there. Kimmeridgian to Tithonian. I don't think they actually have a firm date for exactly how old this thing is. It might be latest Jurassic, or might even be earliest Cretaceous. But yeah. New specimen comprises a denary tooth, an ungual pollex of the manus, and an almost complete hind limb, which was unearthed at the type site of the giant sauropod T. riodavensis. I don't remember what that genus name was. Probably recently described, I would imagine. But yeah, there is that tooth in 3 different views. Kind of semi-typical iguanodontian tooth. Nothing super wild or out of the ordinary there. Yeah. And there is the claw. This is probably a thumb claw, I would imagine. But, well, shoot, I don't know. Let's compare it with our Camptosaur claws here. I could see this maybe being digit 3, middle finger, or it could be the thumb, or who knows, it could even be digit 2. I'm not sure. But yeah. And there is a lovely femur. You can see right here, this part, maybe they accidentally dug through it, or maybe it just got destroyed because of erosion. Maybe some plant roots were shot through it or something like that, but they lost this portion. Had to fill it in with some water putty right there. But they at least know how long the femur is because this part is preserved. Yeah. Very nice. And the femur is, what's our scale bar? 20 centimeters. So that's, it's not a tiny femur, but it's not huge either. Yeah, very nice. And right there, take a look at that tibia. So this is the main shin bone, the central shin bone. Lovely, lovely tib there. Yeah. And look at that fibula. This is the shin bone on the side. The little one. Really nice. So there's some decent material from this animal. We got some metatarsals. We got some phalanges and unguals. Those are the toe claws there. Very nice. Got some drawings of them. And then where does this animal show up on the cladogram? There we go. Oblitosaurus bunueli, Genet Spanov, new genus, new species. And it's coming out outside of Camptosaurus, but sister taxon to Dicatlosaurus, which is like the African Dryosaurus. D. ledoverbecki and D. I wonder if that's the same D between these two genera. Yeah. Interesting. But yeah, there we go. And there's our Oblitosaurus right there. And there is a Camptosaurus, a very large Camptosaurus. So it's actually fairly large, even for a Camptosaur. I didn't realize that. That's pretty cool. That is pretty cool. Anyway. Awesome stuff. Welcome to the world. Oblitosaurus, or I should say, welcome back. Yeah. Very cool. Are these smaller than Iguanodon? A little bit smaller, Baja. Yeah. Actually, a lot smaller than the largest Iguanodon. There's several species of Iguanodon, and some of them get huge. Yeah. Yeah. And Ceratopsian says, have you guys ever heard of magpie? Ceratopsian Sim, I've never heard of magpie, and I certainly don't have any. I certainly don't have any in the art for the channel, like our logo here. I certainly don't have a magpie in that. I certainly did not encounter thousands of really cool magpie when I lived in Bozeman, Montana. Definitely not. No, they're very cool birds. I like them a lot. Yeah. Thagomizer says, I've got to leave now, but fantastic stream as always. Thank you, Thagomizer. I appreciate you being here. You take care. Anyway, let's move on from new dinosaur Oblitosaurus. See who's next. We're now halfway through the month of July. Our next dinosaur here is Eguy. Remember I said that some of our dinosaurs from this summer have got fairly unconventional names? Here's a very cool one. Take a look at this. Yeah. Eguy semku. And I actually heard about this dinosaur last summer before any of this stuff made the news. Because, well, a friend of mine was working on this critter. It was published on July 20th of this year. It's a titanosaur from the late Cretaceous of Egypt. This dinosaur was originally excavated way back in 1977 by a German team, but finally described in 2023. So sometimes people ask me, like, Danny, why does it take so long to publish a new dinosaur? Well, shoot, you got to dig it up. And in this case, with a really very large dinosaur like this, it could take a long time to dig up. Although I think they dug up this dinosaur in one season. Then you got to clean the bone. You got to bring them back to the laboratory. Sometimes they have to go through customs or whatever. You've got to find a place for them in the museum. You've got to open the jackets. You've got to prep the bones and clean them and consolidate them. You've got to get them ready for study. And you got to study them and photograph them and properly reposit them. You have to get your co-authors together and have them study it. You got to photograph it. You got to illustrate it. You got to write it up. You got to get revisions from your colleagues. You got to agree on what you want to do when you publish it. Then you submit it to a journal, and then if they decide they're interested, and they put it through review, and then it's got to go through the peer review process. And sometimes you've got revisions, and those can take years unto themselves. And then once it finally gets accepted, there might be a big backlog in publication, and it might be another year before it actually gets published. So anyway, these things can take a long time. This particular dinosaur sat in storage for a long time before an Egyptian-led team actually studied it and decided to publish on it. But yeah, they chose a very cool name for it too. The name Igai Semku, I think might be ancient Egyptian or modern Egyptian, but it means Forgotten Lord of the Oasis. It's a very cool name. I like it a lot. We'll talk about that. Charlie's Dragon says 1977 to 2023 is a long time in a human lifetime scale, but very short compared to how long since the animal lived. Absolutely. Yeah. Yeah. Very neat. So it seems to be less robust than other titanosaurs. It's got kind of more gracile construction. Its bones are a bit more narrow, not quite as thick. Talk about that a bit. But Egyptian paleontologist Bilal Salem, whom I worked with last summer in the field, he's an author on this paper. So let me find a photo of Bilal from last summer. We might have like a group photo. I bet you we do. So you can see who I'm talking about. There he is right there. Bilal had this very disconcerting habit of... He'd be like, please take a picture of me. He'd be like, okay. And then he'd go and stand on the edge of a 3,000-foot cliff. He'd pose for the photo like that. Bilal's a real character. There's Fisher taking a picture of him. Him and Fisher were roommates for a while last year. But yeah, Bilal Salem. He's a good guy. And now he's got a dinosaur under his belt, which is super cool. He's published a brand new dinosaur, which is an honor for anybody, you know? So yeah. Pretty cool. Igai Semku. That's a great picture. It is, isn't it? Yeah. And so let's take a look at the paper for this critter, shall we? And Igai. There we are. A new Titanosaurian from the Upper Cretaceous Campanian Geysir Formation of the Karaga Oasis, Egypt. There we go. In the Journal of Vertebrate Paleontology, right? JVP used to be notorious for having super long lead times for publication. Like, you'd submit an article and it would get accepted and peer reviewed, and then it would just wait in limbo for like a year or two before they actually published it. I think they've gotten back up to speed nowadays. But there's a lovely figure right there. Take a look at this. Yeah, nice. So here is a skeletal diagram, and the parts in yellow are the parts that we actually have from this animal. So not a whole lot, but pretty good for a sauropod. Sauropods are such a pain in the butt to dig up. And it's cool that we have this much at least. Yeah. Very nice. The Igai holotype contains 5 partial dorsal vertebrae. Yeah, Piscicellus vertebrae. We've got other limb bones and stuff like that, too. There's photographs of some of those bones. It's not the most pretty preservation in the world, but it's good enough, you know? Yeah, you can tell what's going on with them. Could be better. Could be a lot worse, too. And then, lovely, there's CT scans of these showing the pneumaticity inside. These hollows in the vertebrae. Sauropod dinosaurs like this were all full of air. Their vertebral column in particular is just... It's got air sacs and hollows, pneumaticity running all the way through it. Very cool stuff. And holy moly... Dynamite Twins, welcome to Paleontologizing. And thank you for this incredible raid.
Dynamite Twins has arrived in force with their army of 175 chickens.
Fantastic. I really appreciate that. And it's good to have you here. Yeah. Look at all those chickens. Bex in MT. Is that MT like Montana? That's where I used to live. But thank you, Dynamite Twins, for the raid, and how did your stream go? I hope it was really good. Welcome to Paleontologizing. Cat Babble, Citizen, Wolf Mom. How are you doing? Dynamite Twins says, tell us about dinosaurs, oh wise one. I don't know about the wise part, but I'll be happy to tell you about dinosaurs. For anybody who's here for the very first time, let me introduce myself. My name is Danny Anduza. I'm a dinosaur paleontologist, and I'm here on Twitch talking about fossil science. As a paleontologist, you know, I study fossils, dinosaur fossils in particular. And I just got back from about 2 months of field work out in Wyoming and Utah digging up dinosaurs. You should check out some of the VODs if you want to see my live from the field streams. But now I'm back in my office here in the San Francisco Bay Area, and we are talking about new dinosaurs that were published while I was away in the summer, including this one, Igai Semku, a new titanosaur from Egypt that was just published on by a friend of mine. And we're actually... Whoop. How do I go out from here? Yeah, we're going to go over this dinosaur. There we go. There were nine new dinosaurs published this summer, and we're going over all of them. So, I'm glad you could be here. Good stuff. Dynamite Twin says, we love dinosaurs because they're dynamite. They are. Dinosaurs are pretty extraordinary. They're hard to beat, for sure. So, yeah, I'm really glad you could be here, and thank you again for the raid. I hope you had a wonderful, wonderful stream. Now, it seems like we've got some new people here. Like, maybe you? Senior Batovsky? Senior Batatovsky? Batatovsky? Anyway, welcome. Thanks for following. And thank you, Citizen, for the 2 months of support.
It's the dinosaur man!
Okay.
Okay. Thank you, Citizen, for the 2 months of support. I really appreciate that. Without further ado, I'd like to introduce you to somebody whom we call Previously Recorded Danny. He'll kind of tell you what this channel is all about if it's your first time here. Oh, holy cow, and we're getting another raid. This is actually excellent timing. Kinara.
And their 31 raiders came here to experience poultry in motion.
Poultry in motion. Yes, indeed, Kinara. How are ya? And how did your stream go? I hope it was excellent. It's good to have you here. Welcome to Paleontologizing. Welcome, everybody. Kinara says, hello, my dear. Hello to you, Kinara. How are things? Hope they're really good. I'm so glad to be here, back in my office after a couple months of field work, living out in the desert for a couple months. You know what, I gotta admit, it's nice to be back in the land of flush toilets, and Wi-Fi, and I can't say air conditioning, because I don't have air conditioning here in my apartment, but, you know, at least it's not 111 degrees in the shade like it was out in the Utah desert. Anyway, it's good to have you here. thank you again for the raid.
We are leading him into a trap.
Now,
And destroy him with our deadly lasers.
previously recorded Danny is currently sneaking up behind me.
Step-by-step guide to becoming a fossil.
He'll have to wait for a second
Step
though.
one,
Athena Cat,
die.
thank you for the 14 months of
Hey,
support.
Danny, can't believe it's been 14 months.
Incredible,
If you're
right?
feeling a bit
Thank you
cheated,
so much for
try
the
blaming
support.
the dinosaurs.
Good stuff. And thank you for the 100 bits there, Dynamite Twins. Really appreciate that. This hype train might have to continue while we call forth previously recorded Danny, who is champing at the bit. Just wants to introduce himself here, so we'll let him do that. He'll talk about what this channel is all about, who I am, all this stuff. So without further ado, previously recorded Danny, the floor is yours.
Thanks, present day Danny. Now, people ask me all the time, Danny, how did you first get interested in paleontology? And I've always been interested in fossils from the earliest time I can remember, particularly dinosaurs. My parents like to say that I decided I wanted to become a paleontologist pretty much the moment I realized I couldn't grow up to be a dinosaur. And believe me, I tried.
I was born and raised in the San Francisco Bay Area, which is a lovely place to grow up. Except that we haven't got any dinosaur fossils here. So right after high school, I packed up and moved to Montana, one of the best places in the world to find dinosaurs. Just a couple days after I arrived in Montana, I started working at the lab at Museum of the Rockies and the paleontology program founded by Jack Horner. Jack's done a lot of amazing things in his career, but you may know him as the scientific advisor on the movie Jurassic Park.
You consulted on that movie.
I did consult on all those movies.
And they said that the guy, Alan Grant, was you.
Yes, yeah, well, fortunately he didn't get eaten.
But we wanted a credible resource that could back up several theories that we were sort of expounding. And one was that dinosaurs eventually evolved into birds.
And even the word raptor means bird of prey.
And that's something that Jack Horner believes in and could defend if necessary. And Jack Horner became our credibility.
It was in this program that Jack built that I learned how to be a dinosaur paleontologist and how to think outside the box. I've done work at a number of other museums around the American West, helping to prep fossils, design exhibits, and educate visitors. I did a fair bit of eclectic fieldwork in various places, identifying and collecting early Cretaceous dinosaur tracks on the Idaho border, Sphenodontian fossils in the gravelly range of the Rocky Mountains, Cenozoic fishes in western Nevada, but most of my work out in the field was with Dr. Denver Fowler, who is now curator of the Badlands Dinosaur Museum. In all, I've worked probably a few hundred sites throughout the late Cretaceous of Montana, and the Hell Creek and Judith River formations, digging up dinosaurs. Lots and lots and lots of dinosaurs. And from time to time, that work has even garnered some media attention.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
We found its head, we found parts of its armor and plates, and so it should be a new species.
And much like my fieldwork, my research focuses on dinosaurs.
I'm particularly interested in their behavioral functional morphology. All these bizarre anatomical features that certain dinosaurs had, I want to know what they used them for. Right now, I'm working on a study on spinosaurs.
All right, but don't ask me too much about that because it's still a project in the works and I can't give away too much just yet till it's published.
But anyway, a couple years ago I realized that things were definitely headed downhill in Montana. So I packed up and headed back to the West Coast.
And I've become kind of fed up with all the bullshit in academia, so I found myself another job.
I am now a teacher in early childhood education. And let me tell you, it's been a natural fit since day one. Now, given that I get to design the curriculum, my students now know more about biology, classification, and the history of life on Earth than most adults do. I've been helping raise a new generation of young scientists. Then, coronavirus hit. In mid-March, when all the schools shut down in San Francisco, I started holding classes over Zoom, and we picked up right where we left off. 1, 2, 3. I love digging in the dirt with just a pick and brush. Finding fossils is my aim, and so I'm never in a rush, because the treasures that I see are rare and ancient things, like velociraptors' jumps or Archaeopteryx's wings, and all the kids who wanna see them are lining up at our museum. I am a paleontologist. That's who I am, that's who I am, that's who I am. I am a paleontologist. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. I realized that I really enjoy teaching remotely. So back in May, I decided to try streaming on Twitch. And here we are.
This is my passion, and now I get to share it with you. And what could be cooler than that?
I believe that scientists ought to be public servants. Ultimately, it's our job not just to make scientific discoveries, but to teach the public about them. That's exactly what I want to do here. Now, because of COVID-19, this will be my first summer in almost 10 years with no fieldwork. I'm trying to look on the bright side, though. It's not all bad. At least I have more time for outreach, and I've got plenty of cool stuff to work on. And if you could throw some support my way by subscribing, I'd be incredibly grateful.
So anyway, if you are new here, you should be pretty well clued in by now. And I'm glad you're here. I hope you're having a good time. Anyway, let's see what present-day Danny has cooked up for us. All right, present-day Danny, back to you.
Well, thank you very much, previously recorded Danny. And of course, thank you even more to the Dynamite Twins and Kinara for those incredible raids. I appreciate that more than you know. Thank you very, very much. And let me know if you've got any questions, too. We're going through, like I said, our new dinosaurs that were just published this past summer while I was away in the field. Ones we didn't get to discuss because I was out in the middle of nowhere streaming from the deserts of Wyoming and Utah. We're almost through our July dinosaurs and into our August ones. So we're almost done with this, honestly. But yeah. Anyway, and Bex in Montana says, okay, if you are live, please don't answer my Shoto question yet. You had a question about Shoto? Let me look. Yeah. Let's see here. Yeah. Anyway, if anybody's got any questions.
Something about how the world was
80 million years ago. I don't know why that one cuts off short. Skywave Hermit, thanks for the follow. It's good to have you here. Welcome to Paleontologizing. Yeah. And Kennedy's got two questions, one of them Twitch related. Well, let's see what they are, Kennedy. Do you get more on the month at a time subscription? Let's assume if I do multiple at once. It's the same. But a recurring sub is more than a prime sub. A prime sub is like 60% of the revenue to me or something like that. Well, no. 60% of what a regular sub would be, if that makes sense. Yeah. But yeah. Shoto, Montana. Oh no, that's in Rudyard, Montana, Bex and MT. Yeah.
They are impossible to calculate. But then on top of that,
yep.
To actually find the fossil makes the world of the dinosaur hunter the world of the long shot.
Yep, but we were making those long shots left and right this summer. If anybody wants to see those videos of when I was live streaming from the field, digging up dinosaurs live on camera, triumphs and tribulations all, check out the VODs or the YouTube page. Yeah. Skywave Hermit says, very interesting stream. I appreciate you saying that, Skywave. Thank you, thank you. Whoa, somebody's getting serious here. Phoenix, thank you for those 5 gift subs. Extraordinary. I really appreciate that.
Fennec90FR is getting serious with those 5 gift subs.
Really nice, Phoenix. Thank you, thank you. That is good stuff. Yeah. Thanks to you, there are now 5 people in chat who will not have to worry about ads at all for the next 30 days. Plus, they'll get all those emotes, like these and these, and these and these and these. And these too. Yeah. Very nice. I appreciate that, Phoenix. I really do. So yeah. Yeah. Good stuff. If nobody's got any other super pressing questions right now, if you do, type them into chat ASAP. We will go ahead and get back into this. Except, Kennedy says...
Because if they're removed, America loses them forever.
It's true, Ceratopsian Sam. Thank you for subscribing, though. Welcome to the community. It is great to have you here. Thank you for subscribing on a recurring basis. Honestly, it's those recurring subscribers that allow me to do what I do here, so thank you very, very much for that. That's extraordinary. Yeah. Kennedy says, any thoughts? Research more. That's how science works, Kennedy. That's exactly what I'm doing. My work on Spinosaurs is challenging some old ideas that have gone untested until now. But yeah, that... Basically everything in science is like that. It's like, well shoot, this isn't quite right because we have new evidence. Let's adjust our thinking based on better information now. It's just how science works. Yeah. And I'm glad you like the emotes, Confused Echidna. I'm going to be working on some more soon, I hope. Yeah. And you have your YouTube name? It's Paleontologizing, Bex and MT. Yeah.
Reaganation gifted a tier 1 sub.
Thank you, Reaganation, for gifting Confused Echidna, who will now get to enjoy those gift subs thanks to your generosity. Thank you, Reaganation. Yeah. And I've not published the Spinosaur work yet. I'm working on doing that soon, hopefully in the next month or so. Wondergoon, yeah. Yeah. And somebody had a question. Oh, Punisher Max wanted to know about the smallest dinosaur and could it be a pet? I don't know if it would make a very good pet, but I'll show you the smallest dinosaur ever. It has kind of a complicated name. It is called Melisuga helenae. The smallest dinosaur to have ever lived. And it looks like this. It's a species of hummingbird that lives in Cuba. Melisuga helenae, the bee hummingbird. Yeah. It is the smallest living bird, which also makes it the smallest dinosaur to have ever lived, because birds are living dinosaurs. Yeah. Pretty cool. Yeah, so there's its size compared to a hand like mine. A human hand. Pretty small dinosaur there, you know? There's its little nest. There's its little nest. But they're pretty teeny tiny, you know? I think there's a picture of one perching on a penny. There it is. Yeah. That is the smallest dinosaur to have ever lived. Pretty cool, right? Yeah. Anyway, good stuff. Your heart, I know, right, Ceratopsian Sam? Beautiful. I love hummingbirds. They're very cool. They're very, very cool. I just set up my hummingbird feeder again yesterday. Finally had a chance to do that after getting back from the field, and I was outside reading. Starting this fantastic new book dinosaur feeding biology, which was on my doorstep when I got home. Yeah, and there were all these hummingbirds that were like kind of skittish. They wouldn't actually feed out of the feeder while I was there on the chair, but I think they'll get bold enough. I'll get to see them again soon, up close and personal. Oh yeah. Anyway, and HD says, I have a dinosaur nest in the tree by my front door. I bet you do. Yeah. Birds are living dinosaurs. Don't you know it? Yeah. And we've got 9 new genera of dinosaurs that were published just this past summer. And we were just talking about this guy, Igai Semku, which is a new titanosaur published on July 20th of this year. And a friend of mine was one of the authors on the paper, Bilal Salem. I was out digging with him last summer in Utah. So, yeah. Igai. Very cool critter. And now our last dinosaur, published in July of 2023, is Furcatoceratops. So let's take a look at this critter right here. Furcatoceratops. Furcatoceratops elucidans, which means forked horned face that helps elucidate. Explain. Ed Marino, thank you for the follow. Welcome. It's good to have you here. So this dinosaur was also published on July 20th. It's kind of funny. Sometimes it's feast or famine when you've got new dinosaurs. You'll have no new dinosaurs for a long time. We went something like 3 or 4 months this year, 2023, with not a single new dinosaur published. And then we have 9 during the summer. So we're catching back up. Things are going well. So this is a horned dinosaur, ceratopsian, from the late Cretaceous Campanian age, Judith River Formation of Fergus County, Montana, USA. And Ramdoom, thank you for the follow. Welcome. It's good to have you here. So some of you might be looking at this and going, wow, that looks really similar to Avaceratops, or maybe Nasutoceratops. And you might be correct about that. This was, for better or worse, a private specimen that was privately owned, but sold to a museum in Japan. So at least it's in a museum, you know?
That belongs in a museum.
And it consists of a partial skull and skeleton. So there's a decent amount of this animal known, more than most ceratopsians, anyway. Yeah, it shows similarities to Avaceratops and Nasutoceratops. Let's look at the paper. Unfortunately, this is the one dinosaur from the summer that I don't have the paper from yet. It is not an open access journal, and I don't have access to it, and I don't think the authors have responded to my email yet. Let me double check right now. Yeah, nothing yet, unfortunately. So yeah, but I bet you we can find a press release that's not the official PDF of the paper, but, you know, at least something. Or maybe not? It's not on the news anywhere. Though. There, Science Direct, the Journal of Cretaceous Research, which I've published in before. Unfortunately, it is not open access. It is paywalled. But that's okay. Well, here it is from New Dinosaur Alert. There we go. That's better than nothing. There's a diagram of the skeleton. The parts that are there in white are the parts that are actually known from it. The parts that are in gray are the parts that are still missing. So that's actually really, really decent. Not too shabby, and it looks like it's beautiful preservation, like you often get in the the Judith River Formation. So yeah, very, very cool. And so this is a fairly similar dinosaur to like Avaceratops, which itself is immature. Avaceratops right here. There's a pretty lovely Beast of the Mesozoic model of it. Yeah. Furcatoceratops looks pretty similar to it. I wonder how they actually distinguish it from Avaceratops. In fact, I would not be shocked if it were the same critter. Let's look it up on Wikipedia. How do they distinguish it from Avaceratops? It's also a subadult, like Avaceratops, not mature. Yeah, northwest of the town of Winifred, so it's quite near where Avaceratops was found. Classification. Avaceratops holotype. So that's interesting. There's a polytomy right here with Nasutoceratops and Avaceratops. Those might end up being more or less the same animal. That's really interesting. Yeah.
Certainly, there are many more dinosaurs waiting to be discovered.
Like this one.
Many new mysteries waiting to be pondered.
There you go. Chris Allen 26, thank you for the follow. Welcome, welcome. Yeah. And Cheese McSolo, hey, thank you. It's good to have you here. Yeah. And do we need university access to see it? Yeah, you can probably get to it. Sorry, I changed my name. I bet you can look at that article. Here, I'll give you a link to it, and you can try it out yourself. There it is there. I could try my secret back door for this kind of thing. Yeah. And it doesn't look like I can get to it through my shady backdoor science sources. No, unfortunately. Ugh. Anyway, I'm working on something. Maybe I'll be able to have some institutional affiliation sometime soon so I can actually access papers like this. But yeah. Anyway, yeah, and let's see. Somebody was asking if Rizu Dego. Yeah, everybody's back home from our field crew. We are all back home safe and sound in our various different homes. In fact, let me find that was. We've got a group photo somewhere here that I reposted. Yeah. There we go. So this was from toward the end of the field season. Yeah. So there's Justin and Fisher and Ethan and Jim Kirkland. There's Ken and me and Dawn and shoot, what was her name? She was here for a couple days, and now, oh man, completely forgotten her name. But she was cool. Anyway, we're all back home. Justin's back in Salt Lake. Fisher is back in Ohio. Ethan's in Salt Lake too, that's where he lives. Jim lives in Salt Lake. Ken is probably back home near Denver or something. I'm back home in the San Francisco Bay Area. Dawn's back in Park City. And she's also back home in Salt Lake area too. So yeah. Carly, thank you. Lenina. The heat may have fried my brain a little bit back there. Yeah. Thank you everybody for reminding me. So yeah. Anyway, we are all back home in our respective homes. And, Furcatoceratops is not back home in Montana. It has now been sold to a museum in Japan. At least it's in a museum. But, there we go. Furcatoceratops. Lovely. Yeah, so there's a lovely Scott Hartman illustration of the skeleton, what we call a skeletal, short for skeletal diagram. And that's what we actually have of the animal right there in the white. Very nice. Very nice indeed. So not too shabby for the month of July. Not too shabby at all. Yeah. And yeah, so many cool Utah people. Yes, indeed, Moohoodles, including you. Holy cow. Yeah. Now, back to this. We've got but one dinosaur left. After Furcatoceratops. There we go. There's all our dinosaurs from July. Now we get into August. We've got one dinosaur described so far from the month of August. And that is right here. Therosaurus. Tharosaurus? Therosaurus? I'm not entirely sure. This is a sauropod. A Dicraeosaur in particular. Therosaurus indicus. Now, does anybody have a guess where this dinosaur might be from? Given its name there, especially its species name. Therosaurus indicus. Indiana? Not quite. Enough of this. It's from India. Yes. There we go. Published on August 4th, on Nana's birthday. Nana, if you're watching, love you. Hope you're doing well. This dinosaur was published on your birthday. What a cool birthday present. Yeah. It's a Dicraeosaurid from the Middle Jurassic of Rajasthan state in India. We don't actually have a good illustration that's been purpose done for Therosaurus yet that I've been able to find. So this is just Dicraeosaurus right here as a little, like, stand-in. So, yeah. It's known from several vertebrae, plus a rib. Sauropods are notoriously difficult to dig up. They're too big, so having any bones at all is an achievement. So several vertebrae and a rib, it's not the worst, you know? Especially for a dinosaur from India, pretty cool. And hang on a minute. Conrad with a K. Oh, look at that. Look at all those chickens. Thank you, Conrad with a K. I appreciate you. Good stuff. Yeah. Excellent. So yeah. Therosaurus. Its name is a reference to the Thar Desert, which is it Thar Desert? I kind of want to look this up. Let's see if we can find a video on the Thar Desert, maybe. If such a thing exists. A video, not the desert. I'm sure the desert exists. The Great Indian Desert. Let's take a look at this.
Thar. रेत का वो अद्भुत जीवंत समुंदर जो लपेटे
That is gorgeous. Wow.
है अपने अंदर थार की रेत कभी सोने की तरह धमकती कभी चांदी की तरह चमकती करती है अटखेलियां चलती हवा के साथ सख्त मौसम में भी यहाँ खुशी से बसा है इंसान इसके हर कदम पर दर्ज हैं इतिहास के निशान अनोखी दुनिया है जीव जंतुओं की यहाँ
We have the best sand. They might. They might. Yeah.
कहीं परदेसी पंछी है तो कहीं सरहदों की पाबंदी कहीं रेत
Anyway, that is where this new dinosaur is from.
इसके पहनावे इसकी बोली
Very, very excited.
हर धुन
Yeah. And, there we go. Yeah, new Dicrasaurid Therosaurus. Its name is a reference to the Thar Desert. It's the first diplodocoid dinosaur from India, which is exciting. The first member of this particular sauropod family. Sauropods in general are the long-necked, four-legged dinosaurs like this. But Dicrasaurs tend to have fairly kind of shortish necks. They have often long neural spines along their vertebrae, so they often have kind of like a ridge or, you know, sail type thing going on there. So let's take a look at that original paper and see what this dinosaur is all about, shall we? Tharosaurus, there we go. Yes! Open access paper, Nature Scientific Reports. Fossils of the oldest diplodocoid dinosaur suggest India was a major center for neosauropod radiation. So that's the thing. You might only find a few bones of a given dinosaur, but the fact that you find them in a certain time and certain place can tell you a lot about the story of dinosaur evolution. Especially if that's the first occurrence for a particular group of dinosaurs in a place like, for instance, India. So really cool. The abstract starts the early Jurassic and Cretaceous deposits of India are known for their diverse sauropod fauna, while little is known from the Middle and Late Jurassic. Here we report the first ever remains of a Dicrasaurid sauropod from India, Therosaurus indicus, new genus, new species, from the Middle Jurassic, strata of Jaisalmer Basin, Western India. Known from elements of the axial skeleton. So the axial skeleton, that's the vertebrae and the ribs and the skull. There's axial and there's appendicular. Here, maybe I can show you. Axial versus appendicular skeleton. There we go. Yeah, so for a human... I'm trying to find you a decent... There we go. So, in this view, the axial is tan color, appendicular is purple. So the axial skeleton is the vertebrae and the ribs and the skull. Appendicular is the limbs and the hips, basically. Does that make sense? Yeah. There's a weird noise going out there. Let me keep an eye on my 3D printer for a second. I'm going to check this out. Be right back. Car's doing donuts out there.
The evolution of larger mammals into our own existence, for that matter.
It's true. Thank you, Bass Power, for the follow. Is it Bass Power or Bass Power? Are you into music or Osteichthyon fishes? Either way, thank you for the follow. Welcome. Yeah. So anyway. Appendicular versus axial skeleton. Does that make sense now? Axial is the vertebrae, and it's stuff in the middle, basically, along the center line. And then appendicular is the limbs and the hips. Stuff that comes off the sides. You got that? Good. Now, before we get into this dinosaur in more detail, Find It, Fix It wants to know, are the raptors in the movie Jurassic Park about that size in real life? No. Well, it depends. So Velociraptor itself is not that big. This is a Velociraptor skull right here. You know, life size. This is a cast that I got from Rob Gaston. Yeah. So Velociraptor itself is maybe 6 feet long, about 2.5 feet tall. Still not the sort of creature you'd want to run into in a dark alley. It would gladly eat you. But the raptors from Jurassic Park are not actually Velociraptor. They're based on another dinosaur from Montana called Deinonychus, and I have the skull of Deinonychus right there, rotating around on my shelf. That's why they show the velociraptor being dug up in Montana. Velociraptor's not from Montana, but you know who is? Deinonychus. It's kind of a long story, but there was a book published in the 80s by Greg Paul that synonymized, or it sunk Deinonychus into Velociraptor, and they said, oh, Deinonychus should just be a species of Velociraptor, and that's what Michael Crichton was referencing when he wrote Jurassic Park. Anyway, that was bunk, and, but we're stuck with that, because the Jurassic Park novel and movie decided to use the name Velociraptor instead of Deinonychus. It is a cooler name, objectively. Velociraptor sounds cooler than Deinonychus, but whatever. Yeah. So anyway, yeah. But good stuff. And HD and HB says, so a snake is pretty much all axial? There you go. Yeah, just axial skeleton. Because they're just ribs and vertebrae and skull. They don't have limbs anymore. So yeah, a snake is all axial skeleton. As is a whale, for the most part. Whales have still got 4 flippers, but, you know, they've got the remnants of their arms as their flippers. But they've lost their legs and most of their hips, too. Anywho, let's take a look at this dinosaur. Therosaurus. Thorasaurus. Whatever you want to say. Yeah, there's the field site there. In India, very nice. Fairly flat. Yeah. Yeah. Ooh, excuse me. I'm not an expert on sauropods, and so a lot of this stuff is going to be Greek to me. But we've got some differences in the vertebrae, I'm sure. Sauropods really are... Sometimes it seems like they're mostly vertebrae.
32 feet long and 14 feet high.
Horem, thank you, Orhem,
Not a single cavity.
for the follow. Welcome to Paleontologizing. Good to have you here. Yeah. So yeah, we've got some decent material from this animal. Nothing super extraordinary, but enough to show that it's a Dicraeosaur. And interesting, it comes up next to Bahatosaurus. And this polytomy here with these critters. Interesting. Yeah. There we go, but it's pretty early. This might be the oldest Dicraeosaurid in the world, isn't it? Very cool. And so, this is what Earth looked like at the time that this animal was alive. So India was still stuck to Antarctica, which was stuck to Australia, and they're just breaking apart from Africa over here at the time. And so at this time, you could basically walk from India to the northern tip of Australia. And if you swam a short distance, then you could make it to, well, shoot, basically almost anywhere in the world. Pretty cool. So this is during the mid-Jurassic. Those continents are still breaking apart. And, later on, India would break free and would actually drift north before it eventually crashes into Asia. India was an island continent for a good while. So here's Earth 150 million years ago. There's India right here. But if we fast forward to 120 million years ago, it breaks free. There's Madagascar still stuck to the side of it. But then those two have a split there. And suddenly India is an island 90 million years ago. And it will continue to be so. Drifting north, like this. Until it eventually crashes into the mainland of Asia. There we go. About 40 million years ago, something like that. It just plows into mainland Asia, and it is continuing to move north and just push its way, grind its way into Asia like that. And that's what's pushing up the Himalayan mountains. Mount Everest, the tallest mountain in the world, as a result of that collision there. The Indian plate just plowing into Asia like that, and I think subducting underneath it. That's what's pushing up those mountains, which continue to rise to this very day. Gondwana's Revenge. There you go, Ken. Yeah. Gondwana. Or Laurasia, I mean. Yeah. Anywho. Good stuff. So yeah, our dinosaur Therosaurus, pretty neat. So it still looks pretty similar to other Dicraeosaurs because that's the thing, these animals can still move all around and spread their genes and everything else. Only when India becomes isolated do the dinosaurs there get kind of weird. And they start to become sort of unique. When they can no longer, you know, move around, they get isolated and you get weird things happening on islands evolutionarily. You know, dodo birds and moas and dwarf elephants and all kinds of stuff like that. So yeah, pretty cool. So welcome to the world, Therosaurus. Let's see if there's any cool art of this dinosaur yet. Not really yet. That's a Margosaurus right there, which is another Dicraeosaur. We don't know if this guy had the crazy spines on its neck. This illustration says no. But yeah, that's a fairly conservative-looking Dicraeosaur right there. Yeah. So yeah, we don't really know what this animal would have looked like in its entirety because we don't have a whole lot of material yet. But pretty cool. The Weather Channel reported on this, did they? Well, well, well. Scientists unearthed the world's oldest Dicraeosaurus dinosaur. It's not Dicraeosaurus, it's a member of the Dicraeosaur family. Ugh, that's a little misleading. Yeah. Apart from being the oldest known Dicraeosaur, it is also the most ancient Diplodocid, the broader group that includes Dicraeosaurids and their close sauropod kin in the world. That's really cool, and I wish Kerry Woodruff were here to talk about that, because he could talk about why that's so important. Kerry loves Diplodocid dinosaurs, and we gotta interview him at some point on this channel. That would be really cool. Yeah. So yeah. Youth Decay says, are we sure its head is that tiny? We don't have a skull yet from this animal, so we can't say with 1,000,000% certainty that it was. However, when you look at other members of this group, sauropods, their heads are all super tiny. So sauropods, like by definition pretty much, have all got long necks and tiny heads. So sauropod dinosaurs. Sauropod dinosaurs. Sauropod dinosaurs. The ancestor of all these guys had fairly long necks and very small heads, so it just comes with the territory for sauropods. Like, all of these guys have got a very similar kind of body shape. The sauropods like that. And in order for that body shape to work, to have such a long neck, you've got to have a small head. Because think about it, if you had a super long neck like this, or like any of these guys, and then you had a gigantic heavy head, you would be dragging that head on the ground, and you would not pass your genes along to the next generation. So yeah, does that make sense? To be a sauropod, you have to have a small head, just biomechanically, that's the only thing that works. So yeah, Gimpleg says, too bad you won't be going into Peru Cetus. Maybe next week we will, Gimpleg. I think that'll be cool. Maybe on Monday. Yeah. Yeah. Good stuff. And yeah, Europasaurus is pretty cute and tiny, isn't it? Rizadego. Europasaurus, just right over here. Look at little Europasaurus there. So that's a weird thing that happens on an island. Sauropods get really small on islands. Europasaurus is from... Think about the name, Europasaurus. Where is it from? It's, of course, from the moon of Europa. from the planet Saturn, right? No, it's from Europe. And Europe at the time was a series of like small islands in a shallow tropical sea. And in islands, dinosaurs like this, big ones get small and small ones get big. That's what happens on islands. You get insular dwarfism or insular gigantism, which is pretty cool. The planet Nopsha, there you go. Yeah, Franz Nopsha, Ken. See, Ken knows what's up. But, weird and wacky things can happen on small islands where you don't have big predators and stuff. So, here, let's find this. I think it's back over here, right? Where's our insular dwarf? There it is. Yeah, good stuff. Yeah. Island giants and dwarves in this book here. So this is on an island in the Mediterranean. It's the island of Malta, actually. Malta used to have giant dormice and tiny elephants. These are to scale, by the way. The mice, the rodents got really big, the elephants got really small. That's the thing, is if you're a mouse or a small rodent like that, small size is one of those things that you use to defend yourself from predators. If you're small, you can hide, you can evade detection. You know, you're not likely to get eaten. But if there's nobody around to eat you, suddenly you can go wild. You can get really, really big. And then the world's your oyster. Or that small island is your oyster, you know? But conversely for elephants, maybe inversely, elephants don't have to be big anymore if there's nobody to eat them. And on a small island, with few resources, it pays to be small. So elephants can afford to shrink. So you can fit a larger population on a smaller island, and, you know, they might be bite-sized, but there's nobody biting them, so who cares? So elephants can suddenly get small. And so you have stuff like this that happens on islands like that. And that's the same thing that happened with the beautiful little Europasaurus right there. This, right over here, like little Europasaurus there. Yeah, pretty neat. Evolution's amazing like that. It really is. Yeah. So yeah, Ice Allen says that makes sense. Good. I'm glad. Yeah, it almost looks like a juvenile brachiosaur, but I think histo has been done on them. The show Dire Beast Rex, welcome back by the way, the show that they were mature. You know, those are adult animals. And Songery, thank you for the follow. Welcome, welcome. It's good to have you here. So yeah. And oh, Archbishop. Oh yeah, that's an informal name for a particular specimen of dinosaur that's not been formally named yet. But yeah, the rest of these: Vulcimaria, Laparentosaurus, Danosaurus, Bathriaspondylus, Lucid Titan, Pelorosaurus, etc. These are all like officially named dinosaurs. These are all brachiosaurs, I think, or macronarian sauropods. Oh, Vulcimaria isn't. These are among the tallest dinosaurs, I think. That's what they're showing here. Tallest dinosaurs. That's why they don't show Diplodocus or Titanosaurs, because they may not have been as tall. Oh yeah. Anyway. Hope that makes sense. Yeah. So yeah. Echidna says evolution is a series of bugs and bug fixes and our collective genetic codes. It's true. What's this? A chicken? Mr. Bedouin, thank you for the follow and welcome to Paleontologizing. It's good to have you here. Yeah. Let's see. Island dwarfism and gigantism. Maybe we can find a cool video about this. Yeah. Here we go. Here's a different island with huge hamsters and giant owls.
Greek and Roman mythology is full of stories about exotic islands that were home to weird and fearsome monsters, like one-eyed ogres, seductive sirens, and man-eating giants. And I'm here to tell you, back in the late Miocene epoch, there was in fact an island, or maybe a group of islands, in the Mediterranean Sea that was populated with fantastic giant beasts. But these giants were actually
And Hey Huma, thank you for the follow, Hey Huma. Welcome to Paleontologizing.
small. Some of them you might even consider cute. There were enormous hamsters and big fat water birds that could neither fly nor swim, and hedgehog-like animals that were as big as house cats. These organisms were only giants compared to their ancestors, which had lived on the European mainland. But once they became isolated on these Mediterranean islands, some of these little critters attained massive body sizes. That's because geographic isolation is a powerful force in evolution.
This is what we're talking about, yeah.
When the population of animals gets cut off from many of its normal predators or competitors, it gives rise to new species of unusual sizes. Sometimes they turn out to be miniaturized versions of their ancestors, other times giants. The tale of these Mediterranean island beasts of the Miocene is no myth. It's a lesson in the very strange but very real powers of natural selection.
Pretty cool. Yeah, I love these videos. They're usually really well done.
Paleontologists were working in Gargano, a region on the eastern coast of Italy, when they discovered deep fissures or cracks in the limestone quarries and road cuts there. And these cracks turned out to be full of fossils.
Yeah.
For years, it seemed animals had been stumbling into these fissures like natural traps, starting about 8 million years ago. The result was an amazingly rich fossil deposit, a snapshot of life in this place in the late Miocene epoch. But a few things about the Gargano fossils turned out to be really odd. For one thing, scientists were confused about the fossils they didn't find. Elsewhere in Europe, deposits from the late Miocene tend to contain a lot of large mammals, like extinct elephants, cats, and perissodactyls, a group of hoofed animals that include horses. But at Gargano, none of those animals were anywhere to be found. Instead, researchers uncovered an eclectic and bizarre bestiary, including fossils of smaller animals that seemed overgrown. There were extra-large owls, alarmingly big hamsters, and supersized hedgehogs. This strange assortment of animals came to be known as the Microtia fauna. And for decades, the Gargano Peninsula, along with a handful of nearby towns, were the only places on the planet where these creatures were known. Then in the 1990s, fossils of some of those same peculiar animals turned up at Miocene sites near Scontroni, a town in central Italy. So what exactly were these animals? Why were the Miocene animals of Gargano and Scontroni so different from their counterparts in the rest of Europe? For paleontologists, the most likely explanation was that these areas must have been cut off, geographically separated from the rest of Europe.
They were highlands, and when sea levels were higher, like during the Miocene, they were probably islands, right?
Specifically, they were probably islands.
There you go.
Parts of the same
Yeah.
This would explain not only why these animals appeared just at those sites, it would also account for the strange body sizes of animals that were ordinarily quite small. I've talked before about how in island environments, large body animals can often get...
Wait, you have? Why aren't we watching that video? Shoot. Well, maybe we will after this. I don't know.
Smaller over time.
Hang on a minute. Well, let's finish this first. Gah.
For example, in the case of Columbian mammoths on the Channel Islands of California, the absence of large predators combined with limited food led natural selection to
there you go, flawed unrest.
Body sizes. So after thousands of...
We've already covered all the dinosaurs that were published this summer while I was in the field, all 9 of them. So right now we're just kind of tooting around, taking questions, and just chilling and hanging out, you know? Let me know if you've got any questions. Welcome, Flawed Unrest.
Years, some of the giant Columbian mammoths had developed into what scientists consider a new, separate, and smaller species, the pygmy mammoth. This phenomenon is known as insular dwarfism, but it's only part of the story about how island environments can tinker with animals' body plans. The flip side is what happened to some of the animals on Gargano and Scontroni, insular gigantism.
Ooh, yeah. And 586 Smoker says, imagine a 200-foot snake back in dinosaur era. Scary stuff. Snakes didn't get that big. Actually, the biggest snake that we know of in the fossil record is one called Titanoboa. And maybe we'll watch a video about that in a little bit. But that was like 50 feet long or something. And it's from just after the extinction of the dinosaurs. But remind me in a little bit. Maybe we'll watch that.
processes are part of what's
Oh, and Digital Dax says, how many found dinosaurs are there? Do you mean how many different dinosaur skeletons have been found in the whole world, Digital Dax? Or how many different species or genera of dinosaurs? Because if you're talking species or genera, it's something like 2,000. I'm actually working on a project trying to do a reliable tally of this kind of thing. Species, about 2,000. Yeah. Dinosaur skeletons would be in the tens or hundreds of thousands. Yeah. So yeah. Anyway, let's continue.
And Scontroni, insular gigantism.
Yeah.
These are part of what's known as Foster's rule, identified by biologist J. Bristol Foster in 1964. Essentially, Foster's rule says that in isolated
Very funny Colin Robinson.
frequently
During what period did dinosaurs evolve into government-drone birds? It would have been about 160 million years before the formation of the world's first government. So, yeah, that would have been during the probably Middle Jurassic. Which, oh shoot, if you think about it. If birds are government drones, but birds evolved 160 million years before the very first governments came into existence, then that would mean that birds are responsible for governments because they predate them? Oh shoot, we're through the looking glass here, people. Oh boy. Governments are bird drones. There you go, Charlie's Dragon. Anyway. Yeah. Let's continue.
Get smaller, and tiny animals often become larger. And this is what happened to many animals in the Microtia fauna, and it happened because their habitat allowed it to happen. Much like the modern Channel Islands, the regions of Gargano and Scontroni in the deep past were higher in elevation than the surrounding areas.
There you go, like I was
as
saying.
sea levels rose and fell
I promise
over
I've never
millions
seen
of
this video
years
before.
Due to changes in climate, these places became isolated from the rest of Europe and then reconnected many times. And it may have been during one of these periods of low sea levels when some ancestors of the island giants first made their way to Gargano and Scontroni. Researchers think that about 30 million years ago in the Oligocene epoch, a global cooling trend lowered sea levels in the Mediterranean and elsewhere, forming a land bridge between the mainland and these two spots. But then, about 15 million years ago, the climate warmed again and sea levels rose, turning those high spots into islands and severing their connection to the mainland. So maybe the ancestors of the Microtia fauna simply walked across the land bridge before it became submerged. But other scientists have proposed that most of them arrived much more recently, just around 8 million years ago, when the island or islands were properly isolated. In that case, it's thought that the animals might have rafted on piles of floating debris, like logs, branches, and palm leaves, much in the same way that the ancestors of South America's rodents are thought to have migrated from Africa. Either way, once they reached their new island habitats, many of these animals started to follow different evolutionary paths. Some stayed small, and some may have actually shrunk, but others responded to their new environments by getting downright huge. Just look at Dinogalarix, a shrew-like member of the...
What a great name, Dinogalarix, by the way. Holy moly. So this is a hedgehog relative that just... it embiggened significantly upon landing on this island. Holy cow.
The hedgehog family that's found only in these Microtia fossil deposits. Early species of this genus were about 30 to 45 centimeters long, making them only slightly bigger than a modern European hedgehog. But over time, bigger and badder Dinogalarix started to evolve alongside them. The largest species, found only in the most recent deposits, was some 60 centimeters long.
Holy cow, 60 centimeters. For those of you from, an accursed non-metric locale like mine, 60 centimeters, that's the length of this ruler right here. So that's a big shrew right there. And that's just its body without its tail. Imagine a shrew this big. Holy cow, that's pretty large. And today that would be kind of remarkable to go to an island and like see an animal that big and you'd be like, holy cow, that's really cool. This is the point I want to get across right here, is that there are so many times in the history of life on Earth where you have really big, cool, or weird, or different, or interesting stuff evolving, and then conditions change and it goes extinct, or it evolves into something else. The fossil history of Earth is filled with awesome examples like this. Like, honestly, this is a pretty tame one. Like, what? It's a hedgehog relative that got a little bit big. There are, like, yeah, that's cool. That's very cool, especially if you like hedgehogs and their relatives.
Is like.
Distinct, thank you for the follow. Welcome to Paleontologizing. The history of Earth is filled with all kinds of really amazing and amusing and fascinating, wonderful examples of just off-the-wall crazy evolution like this. Earth is constantly changing, usually very slowly, and you get all kinds of wild things that crop up. That's part of the joy of paleontology, is just learning about the crazy, wacky history of life, and it's part of what I'm doing here, is trying to share that with you, you know? So thanks for being here. Let's continue this.
And even though it was a member of the hedgehog family, Dinogalarics had teeth that were more like those of cats and dogs.
And that's pretty neat. Oh, Pipper Papper says, do you ever watch Crime Pays But Botany Doesn't? Yeah, Joey Santori is awesome. I've not actually watched him in a long time, but man, is he doing cool stuff. I'm flattered that you would bring him up on this channel. That is a great, he's an awesome guy. And one of these days I'd like to do a botanical garden visit with him or something, and maybe live stream it, because that would be pretty killer. I think it'd be really neat. So yeah. Anyway, I think he and I in some ways are kind of kindred spirits. I don't know if I can show any of his videos on here, because we've got a kind of a no swearing policy, and you know, he'll use some some auditory spices like that sometimes, but we try and shy away from that. But anyway, I think we are kindred spirits in a way. I look forward to meeting him at some point.
Using its long, pointy incisors and crushing cheek teeth.
Yeah, go for it, Claire Bird. Link his channel, yeah.
Probably behaved like a badger or raccoon, hunting much larger prey than its ancestors ever could. And it did, simply because it could. Back on the mainland, the ancestors of Dinogalarics needed to stay small in order to avoid all of the large predators. But in this island environment, there were very few large terrestrial carnivores. So without the selective pressure to remain small, Dinogalarics was free to expand in size and take advantage of new niches. Its ancestors probably specialized in eating insects, but this animal could have hunted other larger prey, like vertebrates. In the process, it emerged as one of the area's biggest land-dwelling hunters. This was Foster's rule in action. But a big old hedgehog-like
Foster's rule?
still had
I'm not familiar with that.
predators and natural enemies, because these islands were also home to some unusually large birds of prey.
Oh, yeah.
An owl known as Tyto gigantea, which appeared on Gargano in the Miocene. We don't know for sure which species it evolved from, but we do know that there was nothing near its size on the mainland. Based on its fossils, scientists think that Tyto gigantea may have had a wingspan of 2 meters or more.
Holy cow, giant owl.
Of a living barn owl. Likewise, the islands were also home to a bird.
This is the sort of owl where if it were around today, you would not let small children outside at night. Or maybe during the day, depending on when it's active. Because it would just carry them off and eat them.
Of prey known as Gargano aetus, which included 2 species. The larger one probably rivaled today's golden eagle in size, and it's only found in more recent deposits. So this suggests that Gargano aetus, like the giant owl, developed a bigger body size over time. But here's a question. On an island with few other predators, why would these birds of prey get so large? Wouldn't it just mean that they needed to eat more food? Well, some researchers think that on these islands of giants, both predators and prey were engaged in a sort of evolutionary arms race.
Oh, both trying to get big, to out-embiggen the other.
Any rodents whose heads are larger than 17 millimeters. But by being bigger, these birds would have had an easier time hunting and gulping down the local rodents, which were also getting quite hefty. For example, there's the burrowing rodent Macrotia, the Gargano native that gave this whole group its name. One species of Macrotia had a skull that was twice the size of a modern rat's head, suggesting the rest of the animal was pretty big too. There was also a giant species of dormouse, which are usually tiny and adorable, but this one weighed about a kilogram.
Yes!
Which, you know, still sounds pretty cute to me. And then there was Gargano's strange giant hamster Hatomes gargantua.
This is pretty cool. We talked yesterday about fossilizing hamsters. Here's how to make a giant hamster. Is you just isolate it on an island without many large predators, and except for maybe giant owls. But yeah, this is how you embiggen your hamster. Very cool.
It was 3 times heavier than today's common hamster and much bigger than any species that lived on the mainland at this time. Mind you, not all of these island animals expanded in size over time. Small and normal-sized birds and rodents coexisted with giant species. But some rodents definitely got bigger, either because they simply could or because it let them expand into new dietary niches. And as they grew, the birds of prey also evolved larger sizes in order to hunt and eat them. This same phenomenon occurred among other kinds of birds too. Take the case of Garganornis, first recorded in 2013. Garganornis belonged to the same family of birds as ducks and geese, but it weighed between 15 and 22 kilograms, up to twice as much as a large Canada goose.
So those of you who have had unfortunate run-ins with Canada geese in the past can probably report on how fearsome those birds can be, where, you know, without hesitation, they will gladly run after you, and you really think that they're going to kill you and everyone you care about. Canada geese have got some serious moxie. Now imagine a Canada goose were twice as heavy, which would probably mean it's about twice as tall. So imagine a Canada goose like as tall as you are, chasing you down a beach, and just wanting to eat your eyeballs like they're grapes. That's really something. Yeah. Lenina says, no, thank you. That's basically what this critter is. That's pretty wild. Yeah.
Unlike modern
Velociraptor. There you go, Ken. Yeah.
Lower leg bones were really short, suggesting that it spent most of its time walking on land and not paddling in the water. And judging by its bones and its wings, it probably couldn't fly either. So researchers...
Oh, okay. Hang on. That changes the equation too. Holy cow, that makes it so much meaner. Shoot, if a bird spends the majority of its time on the ground, that's going to be a pretty tough, pretty mean bird. Like I've said before, the ground for a bird is a tough neighborhood. You gotta be really, really tough to survive. You gotta be mean. You know, you're from the streets as a bird. So if you're a, like, Canada goose that's twice as big and can't fly, how mean are you gonna have to be in order to survive? Holy cow. It might chill your blood to think about. That's wild.
Think that Garganornis adapted to take advantage of its island's lack of big herbivorous mammals.
Like that cormorant. There you go, HD. Yeah.
Land, it may have been able to...
Oh, but that's a cormorant that exists on an island with no predators. This bird would have had a few predators, I suppose, like those giant owls. But I don't know. Yeah. I guess the fewer predators you have, maybe the less mean you are, too. That's probably a factor in the meanness equation here.
Broaden its niche and forage on a wider range of terrestrial plants, while its size could have helped it fend off some of
There you go, Cobraven. Yeah.
And size adaptations seem to have benefited some larger...
Cobraven says, that's why if you find yourself on Sesame Street, you don't cross Big Bird. he's toughened up from a lack of flight. I mean...
Wait. Just say go. Go.
Anyway, it's less funny when it has the narration in it. But yeah. Anywho, yeah. Flightless birds are not something to mess with. Absolutely.
Mammals on the island too. One herbivore known exclusively from Microtia deposits was the truly strange Hoplitomyrix, a genus of hoofed mammal with...
I'm not familiar with this animal. What is going on with its horns? Maybe it's just the view. Maybe is this one in the center? It looks off center here. And then you've got, oh boy. What in the world? And it's got canine teeth too? Oh boy.
Saber-like fangs and 5 horns on their heads. 5. And there were lots of different species of this so-called prong.
I guess it is supposed, that part is supposed to be centered.
By one estimate, the smallest only weighed around
oh dear,
5 to 6
indeed.
kilograms,
Yeah.
while the biggest may have...
Oh dear, and thank you for your service. Sorry.
And there were lots of different species of this so-called prong deer that varied a lot in size. By one estimate, the smallest only weighed around 5 to 6 kilograms, while the biggest may have tipped the scales at 113 kilograms. And species of different sizes seem to have lived at the same time, which kind of makes sense. Different sizes would make different...
Did we have any mammal people who got that joke? Or maybe not. Thank you for your cervids. Anyway, I'm explaining the joke now. And Dendra Patrol says, does the word gargantuan derive from gargano? I doubt it. Yeah. They might derive from the same root word, possibly. But I don't think it... I don't know. It's a good question. I'm not an etymologist here. But yeah. Yeah.
Different food sources available to each species. This would have not only kept the prong deer from competing with each other, it could have also prevented them from overgrazing their little island. But there was a change on the horizon that none of the weird and beautiful Microtia fauna could adapt their way out of.
Oh, shoot. What do you think this change on the horizon was, chat? Any guesses? What may have happened in order to drive these remarkable creatures into extinction? What? Firearms? Probably not. I don't think that. But this is back in the Miocene, Baha. No, not people, Claire. Now water? The pretty big light? Landmass split? Land bridge. Land connections. Yep. It's almost certainly going to be sea level drop. And this no longer being an island and suddenly, shoot! We're not a beautiful little isolated island anymore. Not ontogeny. They all grew up and died. Yeah, we'll see.
About 5.3 million years ago, a massive amount of Atlantic water passed through the Strait of Gibraltar, which had once been lifted above sea level. This flooded the Mediterranean. Rising water levels dramatically
shrank the island?
Habitat,
I wasn't expecting that.
them to extinction. Just a few million years later, in the early Pleistocene, some areas of central and southern Italy went through a period of tectonic uplift. That reunited Gargano and Scontroni with the rest of the mainland where they remain today. So competition, food availability, predator-prey relationships, and niche expansion. Any or all of these things can very gradually make either pygmies or giants out of animals that are isolated on islands.
Yeah.
It's not mythology, it's natural history.
There you
we
go.
have their fascinating fossil remains to remind us of the odd little giants that once roamed these ancient Mediterranean islands.
Pretty cool. Pretty cool indeed. Let's see if we can find... that Island Mammoths video from PBS Eons too, because the Island of the Shrinking Mammoths, this is going to be good stuff.
Google's Science Journal app for supporting PBS Digital.
Oh boy,
rather
yeah.
Odd find on the Channel Islands off the coast of Southern California.
Ooh, here we go.
Discovered a single tooth from an animal that wasn't known to have lived on the islands, a mammoth. The tooth was a bit on the small side, but it was obviously from a mammoth, and it was enough for...
And again, this is from my own beautiful home state of California here. Because I'm currently streaming to you from the beautiful sunny San Francisco Bay Area. So just off in that direction down there. I'm in Northern California. This is Southern California. But it's cool to see some fossil science from my home state. You know? Yeah. And Pipper Papper, you're from the Bay Area too? Oh yeah, awesome. Anyway, this is Southern California, Los Angeles. You know, whatever. It's still California. Let's continue. Here, let's start from the beginning, shall we? There we go.
In 1873, a geologist named Robert Stearns reported a rather odd find on the Channel Islands off the coast of Southern California. He had discovered a single tooth from an animal that wasn't known to have lived on the islands, a mammoth.
And yeah, Ken, shoot, there might be some flooding in Southern California because of this incoming hurricane. Shoot. This is, Oh yeah, there it is right there. I just opened up Google News and that's the first thing that pops up. Hurricane Hilary could dump over a year's worth of rain on parts of the Southwest. Whew, boy. And that's going to come up through, potentially, Southern California like that. We might get a little bit of rain here on Sunday in the Bay Area, but it might hit Los Angeles hard, and that could be bad. Shoot, I remember... Let me see if I can find this. If anybody lives in Southern California, this might be something you'd be interested in. Yeah. There was a talk at the LA Library by a seismologist. An earthquake scientist. And she was talking about... Oh, shoot. She was talking about the history of earthquakes in LA. And, LA Public Library... I don't know if I can find it, but it was really, really good. She's a seismologist. And she was talking about... Oh, that's it there. Yes! Dr. Lucy Jones, as a seismologist and author, and she was talking about earthquakes in Los Angeles and all this stuff, and then she said something at the end that really, really gave me pause. Where she's like, I'm a seismologist, I study earthquakes, earthquakes are my whole life, you know, I live, eat, and breathe them. And she says, I'm here as a seismologist in Los Angeles to tell you, earthquakes are not the biggest threat facing Los Angeles right now. She said flooding was. And I wonder if I can find that part here, because this is the video. But she said Los Angeles, if you look through its geology, you look at like deposits in Los Angeles, there have been enormous floods that have come through in the Los Angeles basin over the past few 100,000 years. This is just something that periodically happens. You get massive rainfall, and it comes down off of these mountains, and it fills up the LA basin. And she's like, we're due for this in LA. Like, if we get some massive rainfall, you could have the entire LA basin just wiped out by a flood like that. And so it was really wild to hear a seismologist say, like, yeah, shoot, this is what could happen here in our hometown. Here.
If we can't say the gods did this to us, we got to find somebody else to blame, because we really can't accept that it's just random. And as awful as this seems, it's far from the only time that a response to disasters has been to turn on other people. And one of the more difficult...
Oh, shoot, this isn't it. Where is it? So she's talking about different... This is a wonderful talk, and I'll just give you the link right now. Because it is fantastic, and you should 100% watch this in full. This is one of the best science talks I've ever seen, honestly. But she says at one point that preventing damage
is going to be a potentially catastrophic problem. It says if we get it during a big rainstorm, we're going to have landslides, major landslides, like something like we're seeing in Japan right now, but only if it's in a heavy rain time. And I think those sort of results are really quite reliable. Now, one of the things is our predictive power of our model about time.
And Synthberry says, but it never rains in LA. But holy cow, what the rock record tells us is that when it does rain in LA, man, does it rain, to the point where things just flood and everything washes away. Like in the past few 100,000 years, this happens again and again and again. And it hasn't happened basically since LA really grew after the turn of the century. And so like all of these ticky-tack structures that have been built out of stucco and cinder blocks and blah, 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 all of this stuff could just be completely wiped away by a really massive atmospheric river event. You just have a ton of rainfall falling there on the San Gabriel Mountains and the mountains that surround LA like that. The LA basin is basically a big bowl like this. And if you dump a ton of water onto that, oh boy, would it not be good. Yeah. So, yeah.
Is the model that it's random. And all of our testing of that model support that hypothesis. Any model that has tried to have a non-random component beyond what happens with aftershock triggering does not do as well as the random time model.
Anyway, she's talking about earthquakes right here, but where is the flooding part? Risk to society, refugees, evacuation.
You know, the day before the 1906 earthquake in San Francisco was 5 times larger than Los Angeles.
Oh boy.
Los Angeles is now 5 times larger than San Francisco. And its biggest growth decade was the decade after 1906. People walked away and came south. And you could argue that San Francisco...
Oh, 5620. Thank you, Spartan. And thank you, Claire Burr, for bringing that up. 5620. Oh, we're basically here, yeah.
Has never reclaimed what it lost, because it was the only economic powerhouse that mattered on the West Coast. And until Silicon Valley, it didn't matter a whole lot after 1906. So when you think about how do we do this, we need to think not about our individual lives, but about what matters to us in our communities. And I thought I would bring this up and say what matters in this community. Most Californians are pretty worried about earthquakes.
Oh, here it is. Here it is. Ooh, boy. You ready for this?
I look at this and really wonder why you guys aren't more worried about floods.
Yeah.
You know, there was...
She's saying this as an earthquake scientist, too. Earthquakes are like her whole life. And she's like, earthquakes are really, really cool. Holy cow, this is what I study. A flood is what will destroy Los Angeles, she thinks, if it were to happen.
There's a flood in 1861-62 that moved the mouth of the Santa Ana River by 6 miles because everywhere here was underwater. Orange County and much of Los Angeles County, the flats of LA, the LA basin.
And holy cow, we're getting a phenomenal raid right now, everybody. Fantastic. Welcome, Raiders, to Paleontologizing. Stats Bloke, thank you so much for the raid. Welcome to the channel. It is great to have you here. Holy cow. Fantastic. How was your stream there, Stats Bloke? Tell me about it. And John AI 1967. John L.
274 raiders.
Thank you for being here.
Tells us something about how the world was 80 million years ago. I mean, every bone that we find tells us something about how the world
repeat
was.
Alerts.
80 million years ago.
I am Bort. Thank you for the.
Gifted 12 months of
Thanks for coming in with the
Stats
raid.
Bloke.
Welcome, welcome. Everybody, my name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch doing some good old-fashioned science outreach, you know? I just got back from the field. A week ago today, actually, I got back from the field where I was digging up dinosaurs in Wyoming and Utah for about 2 months.
More protection? He simply grew spears which projected from his body armor.
And Stallbearer, thank you for the follow. Postfix, thank you for the follow. Welcome, welcome.
What's science ever done for us? TV off.
It's great to have you here, everybody. Welcome, welcome. Yeah. Earlier today, we were going over... here we go. We were going over new dinosaurs that were just published this summer. In June and July and August, we had 9 new dinosaur genera and species described while I was away in the field digging up my own new dinosaurs. Yeah, starting with critters like this. Anyway, and so we went over a bunch of those. And, yeah, now we're talking about some other stuff. We're actually talking about this upcoming tropical storm, well, hurricane that's heading north toward California from Mexico.
Just ask this scientist.
It could potentially flood Los Angeles, so we're talking about that a little bit. But anyway, normally we talk about fossil science here. We do 3D printing. I'm 3D printing a full-size Allosaurus skull right now as we speak. Here is the lower jaw from that critter. Printing that. And here is the portion of the skull that we have done thus far. All these other fossils up here are 3D printed that you see. Yeah, on this channel we talk about fossil science. I answer your questions. I'm trying to make paleontology accessible to normal folks, you know? Whether that's streaming from here in the office, or digging up dinosaurs live in the field and live streaming that. Check out the VODs from a couple weeks ago to see some live dinosaur excavations. But anyway, we've got a whole bunch of cool new people. Thank you again very, very much, Stats Bloke. Let me know how your stream went, and I really appreciate you being here. We've got a whole bunch of cool new people, and so I want to hand things over briefly to our good friend, previously recorded Danny, who's going to tell you a thing or two about me and where I came from, how I got started on Twitch, what this channel is all about, all that good stuff. So without further ado, he's sneaking up behind me right now. We're going to hand things over to previously recorded Danny. Go ahead and take it away.
Well, thanks, present-day Danny. Well, if you're new here, then welcome to Paleontologizing. You might be wondering to yourself, where's the video games? Well, my name's Danny Anduza, and I'm a paleontologist. I don't really do too much in the way of video games, I guess. I work on dinosaurs. But how does a paleontologist end up on Twitch? Well, I'll tell you. It all started when I moved to Montana right out of high school. In my first week there, I started working in the Paleo Lab at Museum of the Rockies, which at the time was probably the greatest dinosaur museum on the planet. If you've ever seen any of the Jurassic Park movies, then you're more familiar with that institution, and with my old boss, than you may realize.
You consulted on that movie.
I did consult on all those
And they
movies.
said the guy Alan Grant was you.
Yes. Yeah, well, fortunately, he didn't get eaten.
It was in that program that Jack Horner built that I learned how to be a dinosaur paleontologist. I learned a lot of that from Jack Horner's last graduate student, this guy, Denver Fowler, who would go on to become curator of the Badlands Dinosaur Museum in North Dakota. Under Denver, I did nearly a decade's worth of fieldwork, digging at hundreds of sites in the Upper Cretaceous, excavating literally hundreds of dinosaurs. Here's just a few highlights. In 2012, I discovered the world's oldest specimen of Chasmosaurus, hopefully soon to be published as a new species. In 2017, we dug up a brand new ankylosaur.
Montana's news leader.
5 paleontologists are excavating what looks to likely be a new species of armored dinosaur.
So we found its head, we found parts of its armor and plates, and so it should be a new species.
I've also been lucky enough to help collect another very important specimen, the world's smallest and youngest Tyrannosaurus rex. And much like my fieldwork, my research is also centered on dinosaurs. Some of that deals with new genera and species, like this guy, Trurarchuncus, a bizarre little theropod from the very end of the age of dinosaurs, who was just published in July of 2020. I've got a few studies in the works right now, some of them focusing on dinosaur biogeography, and some others on behavioral functional morphology, basically looking at bizarre features of dinosaur skeletal anatomy and trying to figure out why those features evolved. And one of my current projects involves spinosaurs. But I can't really talk about that until it's closer to publication, so don't ask me about it yet. Anyway, let's get back to how I ended up on Twitch. A couple years ago, things were definitely on the decline in Montana, so I packed up and moved back to the West Coast. And I have been so much happier here. I've also realized that I have very little patience for the soul-deadening bureaucracy within academia. So for the time being anyway, I've moved my career in a different direction. And lucky for me, it happens to pay a lot better too. I kind of stumbled my way into a job in early childhood education. I get to make a real difference in kids' lives and help instill a love of nature and a burning curiosity for the world around them. Then coronavirus descended, and the school shut its doors. But I wasn't about to let a global pandemic stop me and my students. We just moved online. 1, 2, 3. I love digging in the dirt with just a pick and brush. Finding fossils is my aim, and so I'm never in a rush, because the treasures that I see are rare and ancient things, like velociraptors' jumps or Archaeopteryx's wings, and all the kids who wanna see them lining up at our museum. I am a paleontologist. That's who I am, that's who I am, that's who I am. I am a paleontologist. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. That's who I am, that's who I am, that's who I am. Having made the jump to teaching remotely, it was only a short leap from there to Twitch. I started streaming in May of 2020, and it's been tremendously rewarding. Now, it's my belief that any good scientist should also be a public servant. In my opinion, talking to everyday people about your science is one of the most important things a researcher can do. Twitch is kind of an ideal medium for that. This is my passion, and now I get to share it with you. And what could be cooler than that? It's my intention to continue this mission of education by answering your questions, providing good science content, and working to grow this channel. And if you could help out by continuing to watch, or if you can afford it by subscribing, I would be deeply grateful. So, for my regular viewers, thank you for sitting through that again. And for everybody who's new, welcome. We've got a fantastic little community going here, and we'd be really happy if you'd join us. Anyway, let's go ahead and wrap this up and get back into it. So, present day Danny,
back to you. Well, thank you very much, previously recorded Danny. And of course, thank you even more to our new friend Stats Bloke. Holy cow.
Did you ever, though?
Thank you for that remarkable raid, and welcome to the channel.
Heartbreaking? I'm
No.
destroying.
No, blue is cheap.
And, Mega Moomal, thank you for the 2 months of support. I appreciate you. Thank you very, very much. Good stuff. You're doing some World of Warships. Oh, very cool.
You're not doing so badly yourself for a paleontologist.
Well, I
In all the
appreciate
world,
the
there are fewer than 40 full-time
kind
dinosaur
words there,
paleontologists.
Gmone. Thanks for the follow. And Sunlake, thank you for those gift subs.
Are leading this expedition.
That is extraordinary, and I appreciate it very, very much. Thank you. Good stuff. Excellent.
5 subs.
Thank you, Sunlight. Thanks to you, there were now 5 people who won't have to watch any ads for the next 30 days.
Really spectacular. Spared no expense.
And Spartan.
So Spartan Zero gifted a tier 1 sub to just Joanne C.
Well, well, well. Thank you, Spartan. These are just going to keep coming, aren't they?
Spartan Zero gifted a tier 1 sub to
Oh.
One Entrance.
Oh, I appreciate that. Thank you very much. Up. And who is this? More from Spartan? Well, well, well.
So Spartan Zero really wants
Spartan.
ukulele with those 5 gift subs.
Thank you for that. That is lovely. It really is. And I appreciate it. Good stuff. Holy cow. Like I said, if anybody's got any questions at all about dinosaurs in particular, because dinosaurs are what I dig up and what I study and what I publish on, or maybe more broadly, you have questions about the history of life on Earth, the fossil record, evolution and extinction and adaptation and ontogeny and anagenesis, all that good stuff. Don't hesitate to bring those questions up. I'm here to do science outreach. Whatever scientific topics people are curious about, I'm here to talk about them to the best of my ability. Zombie Panda, thank you for the follow. Welcome, welcome. It's good to have you. And Cobraven, thank you for those 150 bits. I appreciate that. Yeah. Bidisaurus, Bidiceratops, Bidiraptor. That almost sounds like Bisticeratops, which is a real dinosaur. Or Bistihyversor.
Try blaming the dinosaurs.
And thank you. I often do. Muzokashi. Thank you very much. This is Bisticeratops right here. Yeah. There's also Bistihyversor. Bistihyversor? But I hardly know her. Anyway. Pretty close to Bidiceratops, isn't it, Cobraven? Thank you for the 150 bits. I appreciate it. Anyway, somebody had a question about what my favorite dinosaur species is, and I have a few. It's really hard to pick. I love all dinosaurs, obviously, but one of my very, very favorite dinosaurs, one of the ones nearest and dearest to my heart, is this little guy here. This one is called Triarchunkus prairiensis. That is the species pertaining to that genus, Triarchunkus prairiensis. The name means Captain Hook of the prairie. I sculpted and 3D printed this dinosaur. And to Laser, thank you for that follow. Welcome, welcome. This is one of my very favorite dinosaurs because it's currently the only dinosaur for whom their original descriptive paper bears my name. I'm one of the authors on the paper describing this dinosaur from 2020. Triarchunkus. It's a little Alvarezsaur. The last of the Alvarezsaurs, actually. This one's from the Hell Creek Formation. From the very end of the Age of Dinosaurs. Triarchunkus. There we go. Yeah. And shoot, who's that dingus right there in the author list? That's me. Yeah. There we go. Yeah, should say Danny Anduza. Nobody calls me Daniel, except for a few relatives. But yeah, this is a dinosaur that's very similar to this one. In fact, this dinosaur might be the ancestor of Trurarchunkus. This dinosaur right here.
Mononychus is a desert specialist.
Mononychus, meaning one claw.
Such hypersensitive directional hearing gives her a mental map of this hollow log and what lies within.
Yeah. Yeah. And I actually never met Chris Noto.
She now uses the weapon that gives.
He was collaborating with Denver on the claws of this animal.
Mononychus. Single giant claw. Just what she needs to open a termite's nest.
There we go.
And she has another special piece of equipment. A flexible tongue twice the length of her head.
I love that this Alverosaurids like this critter. They've had this wonderful treatment in Prehistoric Planet.
If only termites weren't quite so irritating.
I love showing off this clip. Yeah. So yeah. That is from Prehistoric Planet, obviously. And this is basically what our dinosaur would look like. You know, like the one in Prehistoric Planet in the clip that you just saw, or like this. This is the general... This is what these animals looked like. Long, stilty, ridiculous legs. Legs that go all the way to the ground. And then super short, stubby forelimbs with a ridiculously large claw for opening up rotten logs or mammal burrows or whatever in order to eat the tasty morsels within. It's a pretty cool critter. And I still need to paint this, but this is my 3D model, 3D print of this animal. Yeah, pretty cool critter. So he looks like an emu. I was kind of going for that, Miss Yvette. There's actually a there's a professionally done model of this animal at a museum I used to work at, the Badlands Dinosaur Museum. Did a good amount of work for them, collected some specimens with them and their crew. That's my old crew chief who runs that museum, Denver Fowler. Trurarchunkus. There we go. A bunch of people have done different reconstructions of this animal. Trying to show what it may have looked like in life, which is really flattering to me. Like, it's one of my little dinosaurs, you know? Trurarchunkus. But possibly the best one is here. New species of hook-handed dinosaur uncovered in Montana. Yeah. And this is a life-sized model that you can see of this animal at the Badlands Dinosaur Museum in Dickinson, North Dakota. Really excellent. And there it is, all covered with feathers and everything. Those are emu and turkey feathers that the artist put onto this remarkable model. That's artist Boban Filipovic from Eastern Europe. JG Staffy, thank you for the follow. Welcome, welcome. It's good to have you here. So yeah. And Dire Beast Rex says, I love that y'all gave it an anteater-like tail plumage. That's kind of a... It's become kind of a meme, I guess, in reconstructing Alverosauroids. Alverosaurids, like this one's got kind of an anteater-like tail plumage too. It just kind of makes sense. I don't know. Yeah. And mine has that too. You know? know, I like that meme, giving it kind of like a giant anteater with its big stupid tail. Yeah. What a cool critter. This was a ton of fun. I actually sculpted this live on stream. So if you go back into, I can probably find it. If we go to the YouTube page, videos, here's all my videos from when I was in the field last month. And in June also. But where's our Triarchunkus sculpt? Where I was sculpting this live on stream. I don't know if I'll be able to find it. But it was a ton of fun. And let's see, if I just search the old YouTube for Triarchunkus. Triarchunkus. There we go. Sculpting this animal. There we go. Yeah, started off with just a basic sphere like this. And then playback speed, let's do 2 point. Let's do 2. There we go. Yeah. Sculpted this from scratch. That was a lot of fun. We got distracted with various things. But back to the sculpt. There we go. Anyway, yeah. And how close in size is your print to the actual estimated size of Triarchunkus? This is about 1/2 to 1/3 the size of the actual adult animal. That's the thing about Triarchunkus, is that we've got multiple specimens, especially claws, at multiple sizes. And so this would be like a small individual, a juvenile, and then the adult one would be like maybe 4 feet long, so like twice as big as this, maybe 3 times as big, something like that. Yeah. So yeah. Anyway. Good stuff. And I'm glad you like the music, Ceratopsian Sam. Yeah. We'll be doing some more sculpting pretty soon, I think. I want to see if I can sculpt a Gastonia Lori McWhinney for Jim Kirkland at some point. Jim, the state paleontologist of Utah, actually just called me up today. We talked for a little while. He's pretty disappointed that I won't be able to stream from Utah later in the summer. But anyway, it's a long story. And have I seen that article, Miss Yvette? I have not. Oh, that's interesting. I'll check this out later, Miss Yvette. Thank you. Yeah, good stuff. Anyway, oh, what a good song. Holy cow, this is excellent. Yeah. Good stuff. Yeah. But yeah, and did we finish up the seismologist video? No, let's get back to that, Ken. I was just about to do that. Thank you for the reminder. So, as a scientist, one of the things that really, really speaks to me is when somebody else in a field unrelated to mine, or maybe related to mine, has some sort of a dire warning for the public at large. Whether it's Richard Dreyfuss's character in Jaws talking about this shark, Carcharodon carcarius. You know? It's a beautiful evolutionary machine that eats and swims and makes baby sharks. Whether he's talking about that, you need to close the beaches, or whether it's about the scientists in Don't Look Up, that movie, you know, warning about the comet that's headed toward Earth, or whether it's a mild-mannered seismologist, you know, earthquake scientists warning the city of Los Angeles about possible disaster. This is the sort of thing that really, really speaks to me. And I hope it speaks to you too. So this is Dr. Lucy Jones speaking before an audience at the Los Angeles Library. She's an earthquake scientist, but she's not here to warn people about earthquakes as much as she is, in this last part, to warn people about floods in Los Angeles. There is the possibility of a flood in Los Angeles because of this big storm that is, shoot, where did that go? There we go. Hurricane Hillary moving up north from Mexico right now. Hurricane Hillary could dump over a year's worth of rain on parts of the Southwest. And that includes the Los Angeles basin, potentially. Potentially. It's hard to track, to predict the course of a storm like this. But it could potentially dump a lot of rain on Southern California right up here. And, oh boy. Yeah, by Sunday night. And so here is a geologist warning about this in, 3 years ago, I guess back in 2020, 2021, something like that. Let's take a look. Yeah, here we go.
Knocked out a quarter of their people.
Here we go.
Of that moment is really about the risk to society. It is not about your individual life. That's what we think of because we're so afraid of that moment. But what really is at stake here is whether or not our societies survive. Societies have been lost. Pompeii was completely lost.
Professor Davis says, would the rain be good for fires there? Aren't there a lot of fires around there? I don't think currently there's too many fires. Potentially there's a few small wildfires that might get put out by fires around Los Angeles and Southern California. But the thing is, too much of a good thing is always a bad thing. Holy cow, that's why it's too much. I was always baffled by that as a child, you know. I would have grown-ups sagely tell me, you know, sometimes too much of a good thing can actually be a bad thing. You know? Isn't that profound? But no, of course, too much is always a bad thing, because it's too much, by definition. Too much of a good thing is always a bad thing. That's why. Otherwise, it wouldn't be too much. And so too much rain on Southern California, especially Los Angeles basin, well, you'll see.
Iceland came very close to being lost from a volcanic eruption that knocked out a quarter of their people. And they cannot be completely lost, but they can lose a lot. You know, the day before the 1906 earthquake in San Francisco was 5 times larger than Los Angeles. Los Angeles is now 5 times larger than San Francisco. And its biggest growth decade was the decade after 1906.
A ton of people moved from San Francisco, devastated San Francisco, to Los Angeles at the time.
People walked away and came south. And you could argue that San Francisco has never reclaimed what it lost because it was the only economic powerhouse that mattered on the West Coast. And until Silicon Valley, it didn't matter a whole lot after.
And this is hard for me to hear, of course, as somebody from the San Francisco Bay Area, you know? I'm used to thinking of San Francisco and the Bay Area as being the center of the universe, like they are in Star Trek. I don't know a lot about Star Trek, but I am from the Bay Area. Yeah. So to hear somebody say this,
because it was the only economic powerhouse that mattered on the West Coast.
yeah,
And until Silicon Valley, it didn't matter a whole lot after 1906.
yowza.
So when you think about how do we do this, we need to think not about our individual lives, but about what matters to us in our communities. And I thought I would bring this up and say what matters in this community. Most Californians are pretty worried about earthquakes.
And again, Dr. Jones here is an earthquake scientist. She's a seismologist. Earthquakes are what she lives and breathes, you know? So what she says next really, really gave me pause. Took me aback.
I look at this and really wonder why you guys aren't more worried about floods. You know, there was a flood in 1861-62 that moved the mouth of the Santa Ana River by 6 miles because everywhere here was underwater. Orange County and much of Los Angeles County, the flats of LA, the LA basin, were underwater, and they were underwater for months. Right? We have had horrible floods in the past. We can in the future, and you really guys should be thinking about that. Not that earthquakes aren't a problem. Why do you think those mountains are there? In California, when you see mountains, think earthquakes.
Yeah.
Something's pushing them up faster than erosion is bringing them down.
Yep. Tectonic forces.
But there are aspects that you get ready for disaster, you get ready for both of them. But prevention requires thinking about your individual risk and understanding it. And that preventing damage isn't just
Poofy Kit Kat says, all right, need to move to Montana now. Might be moving to Montana soon. Gonna be a dental floss tycoon there, Poofy Kit Kat. Montana has its own... Shoot, have you read about the Yellowstone caldera? Oh, boy. Anyway, that'll happen a long time after Los Angeles gets wiped away by a flood, honestly. I'm not saying this flippantly. I'm saying this as an earth scientist. Like, oh boy. Yeah. Sunny Zunny says, who decides what is too much? What criterion? I mean, too much water is enough water that wipes away, you know, it destroys Los Angeles. That's what we're talking about.
Just helping yourself. It's helping your whole community. You know, when a building is badly damaged, its neighbors get red tagged, and you aren't allowed to use its neighbors because it might collapse on you. So it isn't individual financial decisions. It really is as a community. So when you are working on this, do it with your neighbors, because we need to do this together if we're going to have a society that functions. I can't do that alone, but if I'm working with my neighbors and I get together with the churches and with the schools and with the mosques and the synagogues, and we're all in there and connected, we start being able to do something together that means we have a society that can make it out the other side. Because
and this is a critical point. This is... I'm glad I've got 312 people watching right now, because this is something that we are often sorely lacking in today's community. And I feel like, especially on Twitch, this is kind of a thing where, I don't know. I'm guilty of this. I live in an apartment building. I don't currently know a single one of my neighbors in my apartment building. I got to know a few neighbors, and then they moved away recently. So I don't know anybody who lives in my building. And I feel like this is a kind of uniquely modern malady that we have, where people just don't know their neighbors. They don't have a sense of, like, immediate community like that. How many people watching right now, how many people actually know their neighbors' first and last names and could pop over for a cup of sugar, or, you know, maybe you made too many cinnamon rolls and you need to drop some off before they go bad or something like that. Like, this is just one of those things where, like, very few people know that. You do, Bass Smith? Well, that's wonderful. but that's something that's becoming increasingly rare nowadays. This sort of like solidarity among neighbors is extremely rare, and it's not great, you know? Neighbors are scary, says I am Bjord. Especially here in the US, there's just this incredible isolation where everybody likes to... We're kind of trained by society to just hole ourselves up in our houses and not talk to our neighbors and not help each other out. But in a disaster scenario, you need to know your neighbors, you know? We're all in this together at the end of the day, and you know, this geologist here, this is kind of her take-home message, you know? So, yeah.
And with whatever does happen, we're all together with the churches and with the schools and with the mosques and the synagogues, and we're all in there and connected. We start being able to do something together that means we have a society that can make it out the other side. Because in the end, with whatever does happen, we are all in this together.
Yep.
Thank you.
So that was kind of her closing message there, and then she's going to take questions.
Thank you.
And
We'll
Pipper Papper, I know what you mean. I know what you mean, Pipper. Oh, shoot. Where's my closed captions? Oh, they're on. Yeah.
Okay. Here in Southern California, we are on a plate boundary. And the San Andreas system is the set of faults that accomplish the Pacific Ocean moving to the northwest. But it is a system, and there are multiple parallel faults. We have the San Andreas, the San Jacinto, the Elsinore, and the Newport Inglewood. So
beautiful closed captions here, by the way. Those are going really well.
There are
and I apologize, too. This is the Newport Beach Library, not the Los Angeles Library. Mea culpa, I got that completely wrong. I apologize. It's the Newport Library at, I guess, Newport Beach.
Also a couple hundred other faults here in Southern California because we have a bend in the plate boundary and we have a lot of complicated things. The San Juan...
Uncle Bill says, I'm rural, and there are still only a couple of nearby households that I'm on sharing terms with. Not all the community spirit I remember from my childhood. And that's the thing, is that in our modern society, we are discouraged from getting to know our neighbors and having a sense of community like that. Think about it like this. Say you have a neighbor who is a carpenter, and she has a bunch of saws and drills and stuff like that. How comfortable do you chatters feel in, like, going to your neighbor to borrow a power tool like that? You know? Probably not very comfortable. There are forces in our society that encourage you to just purchase one off of Amazon or whatever. To buy it online. Just have it delivered to your house in 24 hours. Rather than just, you know, something that you might use once every 5 years. You know? A jigsaw or something like that. Oh, I'll just buy it. You know? It's just easier. Rather than just borrowing it from your neighbor. Having a nice conversation. Maybe they come over, they show you how to use it, and you're building community like that. Especially here in the United States, we don't have that kind of thing anymore. Because people profit off of our isolation.
Global and serious game of paleontology.
Ciardi, thank you for that follow. I appreciate that very much. Welcome to the channel. So yeah. When was the last time you popped over to a neighbor's place to ask for a cup of sugar or to offer them some oranges that grew on your tree or something like that? Like, that's the thing, is that, like, frankly, our economic system, capitalism, profits off of tearing people apart and just creating these rifts, making everybody, like, rugged individualists. We're like, oh, I don't want to talk to my neighbors. You know, I need to buy everything for myself. And that's not, those are not the conditions that human beings evolved under. That goes against human nature. And it makes us sad. It makes us depressed. It isolates us. It makes us unhappy. That's not the sort of thing that's not how we're supposed to be. So anyway, yeah, I'll step off the soapbox now. We'll let Dr. Jones continue.
Fault and various other faults. In terms of
and introverts unite. I mean, what? Shoot. I mean, okay. Back up on the soapbox for a second. I realize I'm here on Twitch right now, and Twitch is one of these platforms where, you know, this definitely caters to people who are kind of introverted, you know? And that's fine. You know, it's fine if you're not a particular sociable person. If you're not, you know, super extroverted, that's totally okay. You know? People have got different personalities. But when you don't have, like, when you don't know who your neighbors are, I mean, shoot, that's kind of crazy. When you really stop and think about it. 100 years ago, you would have known all of your neighbors, I'm sure. But our modern age is just, everything's built around separating people from one another. And yeah, that's not healthy in the long run. You don't have to have a million friends or be super sociable or anything, but like, not knowing who your neighbors are is, at the end of the day, that's, I don't know, think about that. Is that really ideal?
Stegosaurus, 25 feet long,
Miggity Marty.
4 tons. A versatile sort of chap. He won a lot of arguments in his time, but very few beauty contests.
Thank you, Miggity Marty, for the 6 months of support. I appreciate that very, very much. Appreciate that. Yeah. There. Let's get back to this.
Risk. Well, the risk, it's going to be the one that happens to go in your lifetime, right? And that's that random subset problem. But your chances of anyone going are going to depend on how fast the fault is moving. So on average, the San Andreas has a big earthquake once every 100 years on any one part of the fault. The San Jacinto fault is maybe 1 to 200 years. The Elsinore fault is maybe once every 5.
Ken says, the coprolite got real here for a minute. There you go, Ken. Yeah. Yeah. Shoot. You know, whatever. It's Friday. Bassmith says, I wonder if the collective step away from a religion that has happened in the U.S. has contributed to that isolationism. I feel like local churches were social clubs that encouraged that sort of collaboration and community, and nothing has taken their place. That's part of it, Bassmith, is that sort of thing just isn't profitable, you know? You even see this in church communities where, like, I mean, shoot. Even a lot of, like, self-professed religious people have kind of given up on religion and, you know, taken up, like, right-wing politics in its place. There are people who, you know, Trump has taken the place of God in a lot of religious communities, which is kind of crazy, but you see it everywhere. And that's the thing, is that, like, that's a huge societal force. And it's almost impossible to overestimate that. So yeah, community in general is one of those things that's just, it's kind of disappearing from modern society. And the more isolated people are, generally, like, the more money they have to spend in order to feel connected to a sort of community. And that's, yeah, I don't know. If more people were part of churches or synagogues or mosques or bird-watching clubs or Dungeons and Dragons clubs or, you know, science groups or reading clubs book clubs, whatever kind of community that you can find yourself in. This is something that is like core to our being as Homo sapiens, as human beings. We need community. And especially after COVID, COVID was like a real driving force against us, because for a while we had to all stay away from one another to avoid, spreading this horrible disease. And that's really kind of fractured a lot of society. And I think a lot of people are still kind of recovering from that. And that sucks. That's really lousy. Like it's really bad for people's mental and spiritual health, It's not great. So anyway, knitting circles. There you go, a truck horn. There you go. Yeah. Meow House says I work too much. That's another thing too. Rents are going up while wages stay stagnant. So what do? Shoot. People are pressed in from all sides. It's tough in our modern age. It really is. Yeah. Miss Yvette says, I have meetups. That's a wonderful thing. Holy cow. Like, we crave that as human beings. That's part of who we are, is we want that, that social interaction. So, anyway. Yeah. And society's just weird. Cold Drake. I mean... yeah, science has lost its allure? I hope not. Shoot, I'm a scientist myself, Coldrake. I hope science hasn't lost its allure. Yeah. But anyway, bring back the block party. There you go, Uncle Bill. That is something. Yeah, shoot. Chat, I might be moving at some point in the next few months. And if I do, I'm hoping that we have kind of like a block party, community party kind of thing when I move into a new neighborhood, and like I get to meet my neighbors and figure out who lives near me and would establish a kind of community like that, because it's, and not something based on Nextdoor where people are calling the police on because they saw an opossum in their yard or whatever. Anyway. Yeah. Weren't those called barbecues? There you go, Coltrake. Yeah. Anyway, shoot, let's continue.
Years,
yeah.
And this Newport Inglewood is once every 1,000 years. So you're more likely to get a San Andreas. However, if you live here, the Newport Inglewood's going to be a lot worse because of that whole problem with the dying off with distance, and when you're right on top of it, it's a lot worse. We actually have some really cool new data that's come in about Newport Inglewood Fault at Seal Beach. People went in looking for tsunami deposits, couldn't find tsunami deposits, but they were able to see.
And hang on a second. Artista Girl makes a good point here. Artista Girl says communities are replacing the societies because we choose our society by connecting to the communities we want to be in. It's more comfortable, I'd say. It is a 1,000,000% more comfortable, yes. Because if you choose the sort of community that you're a part of, then those are people who are more similar to you in your interests and your values and everything else. But here's the thing. They might not be closer to you in proximity. And like we're talking about here, with this geologist talking about natural disasters, physical proximity counts for a lot. Whether you're trying to borrow a cup of sugar in order to make some muffins from your, borrowing a cup of sugar from your neighbors, or whether you're trying to survive a natural disaster in your particular neighborhood, that proximity counts for an awful lot. And so online communities are one thing, and I am tremendously grateful for the community that has grown here around paleontologizing. This is truly remarkable, and I've been able to make my living through the support of this wonderful community. But this is not... Well, yeah, shoot, if we need to fund some fieldwork in Wyoming or something like that, this community has really come in clutch through that and helped us do that, which is incredible. But if I needed to borrow a cup of sugar because I'm making some muffins, you know, that's a different story. Or if there was a natural disaster in my neighborhood, you know, say there was a Godzilla rampage and my neighborhood, you know, Godzilla just came through Richmond and just leveled everything. You know, if I needed to borrow a cup of sugar after that, then, well, shoot. You know, or if I needed bandages for a sucking chest wound or something like that, well, good luck. That's the thing, is that community online can be tremendously meaningful and can bring people a lot of happiness. But when it's in a physical space, that's something different. It needs to be like, you know, in close proximity around where you live, you know, and a lot of people can't find meaning online, you know. I'm talking to an audience right now. All of you right now, you have found meaning and community here on Twitch in this online space, but not everybody can do that. Some people, you know, they don't like computers, they don't understand them. They need that like face-to-face interaction in real life, and yeah. Does that make sense? I hope it does. Yeah. Go close, wear a mask. There you go. Roger and out. Yeah. So anywho, let's get back to this.
See a feature that was created by the Newport Inglewood Fault, moving and pulling things apart within there, and that's where we're getting, it looks like we have 3 earthquakes in the last 2,400 years, and bigger than
Lenina, the feeling's mutual.
So it's a real risk when it happens. Less likely to happen, worse for you when you got it. All right. Disclaimer, I no longer work for the U.S. Geological Survey, so I'm not privy to what the various plans are. That said, I am still at Caltech, and so I'm at the edge of the development. We have, the software's there. It doesn't work perfectly.
And Golganek says, I'd be blunt. Depending on where you are and who you are, society can be dangerous. This is true, Golganek. Holy cow. Especially if you're part of like a marginalized group. You know, shoot, if you're a minority group, if you're indigenous, if you're trans, if you're part of a minority religious group or something like that, then like sometimes people in larger society can be downright hostile toward you. And I don't want to discount that at all, Golganek. You're a 1,000,000% right about that. But I'll also say this, like, I think most people are generally good, especially if they get to know you, you know? And maybe I'm speaking from a position of privilege here where, like, I tend to get along with most people, I think. I'm not, you know, prickly or anything, or, well, sometimes I don't know, whatever. But the more you know people in your community, I don't know, the chances are that you'll meet somebody who you can really vibe with and, like, they can help you out in a natural disaster scenario, whether it's an atmospheric river flood or an earthquake or a Godzilla rampage or whatever else, you know? Yeah, I don't know. I think community is generally a good thing. There are probably a lot of people on Twitch who have had really bad experiences with just really nasty people in real life. And I totally understand that. There are, I don't know, there are definitely scenarios and like forces in life that like try and get people to be nasty toward other people. But for, you know, there are a lot of good people in the world who, I don't know, this is speaking for me here in the San Francisco Bay Area, of course. People here tend to be generally pretty nice and accommodating and tolerant and like, you know, cool. I'm a person, you're a person, let's get along, you know? It's not like that in every part of the world, and I recognize that. So I don't want to discount anybody's experience on that front. But, yeah, I don't know. I still think, more often than not, community is a good thing. Getting to know your neighbors, generally good thing. At least so you know, if you get to know your neighbors, then you start to realize these people, they're cool. And they're cool with me, I'm cool with them. Those other people, shoot, I should stay away from them. If you know your neighbors at least, you can kind of vet them a little bit. You know? I think it's a general net positive. Yeah. That makes sense? Yeah. So, yeah. Thalo says, so the upshot of all this is we're all going to live next door to Danny and have dinosaur parties? Hey, I'm all for that, Thalo. Yeah, I'll bring the wine, says Meow House. There you go.
Blaming the dinosaurs.
Danny, I am so incredibly happy you are back.
Thank you,
I love the
Trappy.
field streams, but it's so nice being back in the office with
Thank
a
you.
lot of great props. Thank you for being one of the best science educators on Twitch.
I appreciate that very deeply, Trappy Jenkins. Thank you, and it's good to have you as part of this community, Trappy. Appreciate you very much. Let's continue with
And
this.
that really upsets scientists, right? We really think perfection is really important, and you should never underestimate the ability of a scientist to put perfection in front of timeliness. So we've been running a pilot system for 6 years, and it's not perfect, much improved, right? We get warnings. When will it go public? Well, to make it really work, you need a lot of stations. So the earthquake early warning system is basically the seismic network we already have that tells us when and where an earthquake happened. And if we can do it quickly enough, we can get you that information before the wave gets to you. You know, when I do this, you can't tell the time it takes for my wave to go out there, but it's about 2 miles a second, and if it's 100 miles away, we can get a lot of time.
Yeah. Shoot, that reminds me.
Is the only
I really ought to re-download that app. What was it? MyQuake, something like that. I deleted that on my old phone because my old phone was super slow and running out of space. I should re-download that app.
Country that has enough seismic stations to be pretty reliable, partly because the mayor of Los Angeles used Homeland Security money to add over 100 stations to our system. So we actually, all of Southern California is in decent shape. According to the mayor, of course, who doesn't control this, it will be going public in Southern California in 2018. And which is partly him pressuring the USGS, but I think they're going to be going ahead and doing it. So I think there will be some public version very soon here. They are worried about the political consequences of doing it for here and not San Francisco. Mayor Garcetti goes, yeah, well, that's why we put up the money. Can we get something out of this? That's the intent. There is a working system. All right, there's a working system. How do we get it to you? The phone companies have been insisting that they can't, that it takes 10 seconds to go through their system. There's the WIA system, that takes like a minute. If you get an Amber Alert, that's a minute or two before.
Oh boy, what was that app? It's not coming up in the Google Play search, so let me look this up real quick. Earthquake. It's called MyShake. Why is that not coming up in Google Play search? Do I already have it downloaded? Is that the idea? Is that what's going on here? It's not on there. Why is it not showing up? What's up with this? I'm about to be... There we go. From UC Berkeley. Excellent. I just got a new phone this summer, and I'm, my old phone wasn't really up to the task for this, but this is a really, really cool app because if you are within an earthquake-prone region like the west coast of the U.S., this could potentially be a lifesaver. Let's take a look at this. Why is it muted? Let's try it again.
Hi, my name is Richard Allen, and I'm the director of the UC Berkeley Seismological Laboratory. I want to tell you about a research project that we have to collect a new generation of data that we can use to reduce the impact of future earthquakes. To do it, we need your help. We want to use the sensors on your phone to record the impacts of an earthquake so that we can understand them. But in the near future, we hope...
And so for me, I have data turned off on my phone all the time, and location also, because that drains the battery. But I'm usually, for like the majority of my day, within Wi-Fi range here in my apartment, and so I just have the phone run off of the Wi-Fi, and then it can use this. So if I happen to be at home in my apartment, which I suppose is at risk of collapse during an earthquake, then I'll get a potential notification if an earthquake is incoming.
To use it to be able to send a warning out to you and other users of the MyShake app in order to give you a few seconds warning before the shaking starts.
There you go.
It works best when you actually have your phone on a stable table. So all smartphones have an accelerometer which allows the phone to sense motion, whether you're walking, whether you're running, the orientation of the screen. We use that data to be able to detect earthquakes. When the earthquake strikes, the accelerometer in the phone will record the ground shaking, send that data to our system. We can use that data to understand the physics of the process beneath us, how the buildings around us respond to these earthquakes, and we will have more data than we have from the traditional seismic networks.
Interesting.
MyShake can improve earthquake early warning in places with traditional seismic networks, like the US. But in other parts of the world where there are no traditional seismic networks, there are still millions of smartphones. So MyShake could bring earthquake early warning capabilities to those regions too. Right now, it's only available for Android. The free download is available from the Google Play Store.
There you go.
MyShake doesn't interfere with any other applications on your phone and uses only minimal power. With the help of thousands of you downloading the app, we'll be able to more rapidly move to the next generation of MyShake and actually start providing alerts. With your help, we're going to change...
Hang on a minute. How old is this video? Because they already provide alerts. This is from 7 years ago? Sorry. This is already a thing. Here we go.
On the eve of the 30th anniversary of the Loma Prieta quake, a new system is rolling out that could radically improve how we respond to earthquakes, including the big one. Nightbeat's Mark Sayre visited USGS tonight to show us how it's going to work.
30 years ago, nobody had any advance warning
of
the quake, but technology and communications have changed, and starting tomorrow, an early warning system is coming to your phone. In 1989, the first sign that people had
the Loma Prieta quake.
when the ground started.
Holy cow, that killed so many people here in Oakland, where there were multiple like double-decker freeways that pancaked and just smushed everybody in between these different like, you know, one highway falling onto another one. They just completely demolished those afterwards, and that's just like an open promenade now. There used to be all these double-decker freeways that ran along West Oakland.
It's one of the scariest days of my life, going through that earthquake.
But tomorrow, the State Office of Emergency Services will roll out the MyShake app statewide,
There you go.
which could give valuable seconds of warning.
With earthquake early warning rolling out, you know, if you get an alert, then you can start to take action before the strong shaking hits.
Earthquake early warning systems are listening for the very first signs of an earthquake, and that comes in what's called the P wave. That's the initial or primary wave of an earthquake.
That's what I learned in Geology 101.
Then the more damaging S waves.
We have sensors spread throughout all of California, particularly in the Bay Area.
This guy here. This is like your archetypical laboratory scientist here, who he's so excited to be on camera. Holy cow! Like, this is something he studied for his entire life, and he is just thrilled to be able to explain this. Oh man, this is so many of my colleagues right here. Same archetype.
We have sensors spread throughout all of California, particularly in the Bay Area and the LA area.
Let me explain my thing, says George from New York. Exactly. Yeah. He's so excited that people are actually listening. Exactly, Charlie's Dragon. 1,000,000%.
Not only will you get an alert with the app, but also on your phone, the same way Amber or other emergency alerts are issued now.
I mean, a lot.
Yep.
I mean, if you can just get yourself into a doorway or something and stuff starts shaking, so you have a jam around you, or get under a table. Had this system existed in 1989, San Francisco and Oakland might have had about 10 seconds of early warning based on the distance from the quake center.
How much notice you...
Yeah, because that epicenter during the 1989 Loma Prieta quake, the epicenter was in Loma Prieta, which was like 100 miles away or something like that. So, if you could have had a notice that went out to every phone in the Bay Area, saying like, "Holy cow, there's an earthquake!" Like, there would have been a lot of people who would have gotten that message and would have gotten under a sturdy object, under a desk, under a table, and a door jamb, something like that. Fewer people would have been crushed by debris.
It really depends on how far you are away from the earthquake.
The MyShake app has been in the testing phase for the past year, but it's already available for download. On the Night Beat in Menlo Park, I'm Mark Sayer.
And we've posted a MyShake tutorial online for that and instructions on how to set up the MyShake app. You can head to the web at kpix.com.
Anyway, yeah, there you go. So this is from 3 years ago, by the way. Holy cow. I'm sure the app has improved significantly since then. I just re-downloaded it because my old phone, which was falling apart, wasn't really up to the task. Yeah. But this one, it should work pretty well. Let's see. MyShake. There we go. Yeah. There's an app here in New York City that's been testing tsunami alerts lately. That is interesting. I wonder what the tsunami risk is for New York City. I wouldn't imagine it is super, super crazy, but I don't know. Yeah, here, I'll do this later when I'm off stream. But, yeah. Why the EQ talk? I don't know what you mean, Baby Bat. What do you mean by EQ? Huh? Anywho, yeah. We've got a new chat here from, who was that? Canon PDX says, is it true that we can use sheep's bladders to prevent earthquakes? I don't know what you mean, PD. No, it's not true. What? What have you been saying? So earthquakes are caused by tectonic forces. That has nothing to do with sheep's bladders. I don't know what you're talking about. Yeah, here. We got off on this whole tangent about natural disasters and community and everything because of Dr. Lucy Jones here giving this talk about Los Angeles and natural disasters that might befall that region. Let's continue
to your phone, which is useless for early warning. AT&T now says they can do it because they got to. So there's something being developed. That's one of the big issues. I think it's going to be available through the internet. So at least if you have your computer connected to the internet, you can get it pretty quickly.
There you
they
go.
also haven't spent
Yeah.
the money they should have on
This is what we're talking about, the MyShake app.
and education. All of those are
Hey,
pieces
Mayor
of
of Space, what's going on?
coming
Good to have you here, Mayor.
Okay.
Oh, and Ken says not much of a Monty Python fan, I see. Oh, I'm sorry, Ken. I that reference flew and sailed over my head. You know, like a European or perhaps African sparrow just sailed directly over my head. I apologize, Ken PDX.
That's a huge caveat. I also, I'm not, all right, we don't have a subduction zone here. We have tsunamis that can come in from Alaska, which will have a couple hours warning. We do not have a local source to create a tsunami as we saw in Tohoku.
She's talking about in Southern California, around Los Angeles.
I don't know the heights at which they are planning for there. I will tell you that when I was with the U.S. Geological Survey, we had first created this scenario of what a big earthquake would be, what we call the shakeout scenario.
But in the serious game of paleontology, much larger mysteries still remain.
Questionable piece of cake. Thank you for that follow. Oh, boy, that reminds me of that Seinfeld episode where Elaine ate that piece of cake, disregarding the warnings of Mr. Peterson. Anyway, welcome, questionable piece of cake. I'm glad you're here, and thank you for following. Yeah, Earth Science friend, how you doing? Hey, X-Tina, how are you doing? Welcome, welcome. I'm doing quite well. Back home after field work. Settling into civilized life once again. There's some positives, there's some negatives, but I'm here back in civilization, and I'm okay with that.
We also created a tsunami scenario. So we tried for 3 years to get the biggest tsunami we could into here, and we were really frustrated because we just couldn't get a very big tsunami in here. And it's, it was an interesting thing that on the earthquake, it was like people were basically planning for the right thing. On the flood, they way underestimated what the real risk is.
Sorry about that.
And on the tsunami, they overestimated what the risk is. So the biggest tsunami we were able to create requires putting a Tohoku-sized source in exactly the right part of the Alaska Trench to aim it at us. And that's a much bigger tsunami than we would get from anything like from the Pacific Northwest or any of the other sources.
Interesting.
And that brings in about 2 meters to this region.
That's not a lot.
It does cover Balboa Island. That's one of the few places that's completely inundated in a tsunami. 6 feet, something like this, above sea level.
So, the Los Angeles Basin, LA in general, not at risk from tsunami inundation. But maybe anyway, that's interesting. LA doesn't really have to worry about tsunamis. It's more earthquakes and floods from too much rainfall that it has to worry about. I just heard an unusual noise from our 3D printer. Is our 3D print finished? It is. Holy cow. We might have to add this extra part of our Allosaurus skull here. Holy moly. For those of you who are fairly new to the channel here, well, allow me to introduce you to our Allosaurus skull that we are currently 3D printing. Let me grab this off of the old 3D printer right now. Holy moly. There we go. Lovely. Very excited about this. Let's go ahead and get this assembled, shall we? We've been printing a life-size Allosaurus skull. About 83 centimeters long, close to a meter in length. Allosaurus is one of the top predators of the late Jurassic Morrison Formation of North America, places like Colorado, South Dakota, Montana, Wyoming, and of course Utah. Utah probably has the most Allosaurus specimens of any U.S. state. And there we go. We've got a... Yep, need a little bit more cleaning on this. There we go. Yeah. We can go ahead and attach this to our Allosaurus skull. We've been printing a life-size Allosaurus skull here. And I am stoked for this. We've got another piece to add. Come on now. Got a few pieces that are holding on, bits of flash and supports that I could honestly probably clean later after assembly. But just trying to be thorough about this. There we go. Nice. All right. Check out this new 3D printed piece of our Allosaurus here. Very, very nice. Let's go ahead and get this bad boy adhered onto our Allosaurus snoot. This should go on right here, right? Almost perfect, but we've got a few bits of connective material to remove, perhaps. Not on here. Why isn't it connecting properly? Come on now. There we go. No, that should do it. Very nice. In fact, we might need to sand down that connector just a little bit. Let me get my sanding stick. But let's do that. Yeah. There's no original picture. No, holy cat, there's definitely an original picture there, Chappie Jenkins, and it looks like this. Right now, we're assembling part of the posterior maxilla, which is one of our skull bones there. And if you're a paleontologist, a vertebrate paleontologist in particular, then you know exactly what this is. Yeah. So, yeah, very nice. Here is a sanding stick, so let me make sure that our connecting pieces don't have too much 3D printed detritus on them so they don't occlude properly. Now that should be... Hopefully that should be very nice. That should work out nicely there. So, on this side of our Allosaurus snout, we already have the posterior maxilla right here, but we need it for the other side. Over here, this is missing. So, Let's see. Got a minute. There we go. Very nice. That is how it is supposed to go. Beautiful. Let's get that glued up, shall we? I was not expecting a stream for this long that we would actually be able to assemble this, but that is good stuff. Let me get my adhesive, and we'll get this thing put together. There we are. Here is my 3D gloop. This is our adhesive that we use for this. Really excellent stuff. I'm gonna run out pretty soon, but luckily... Wait, do I have more on the... I don't think I have more on the wish list. Let me put it on there. 3D gloop. Oh shoot, where did it go? Is it not available on the Rainforest website? Amazon? It's straight up not available. Well, shoot. That's okay, I guess. I guess I'll just run out. There we go. Here's our desk setup. And I'm going to be painting some adhesive onto these surfaces here, our occluding surfaces, so I can put those onto our Allosaurus model here. Yeah. There you go. Won't be too long till we run out of this stuff, which is a shame because it is lovely. I really like this 3D gloop. It is good stuff. It actually helps melt the plastic so that it adheres properly. And blink, there we go. Lovely. There is our new piece right here. Sorry for the soundboard buttons I accidentally hit. But there we go. And that should be a nice fit right there. Very good. Very good indeed. Lovely. Oh, our Allosaurus skull is really coming together. I am excited about that. Very nice. Fantastic. We're gonna have a whole skull of this animal pretty soon. I mean, right now, there's that. We already got that snout right there. You see it? There's the nares, the nostril. There's the big antorbital fenestra. Yeah. Pretty soon. Sooner than I expected, we'll have this whole thing done. Very excited. And you know what? Shoot, with that being said, I've been streaming today for 5 hours and 40 minutes? Holy cow. I had to wrap this thing up. I'm sure the sun is getting ready to go down here in the San Francisco Bay Area. It's about time to wrap up this stream, I think. So, without further ado, let's go ahead and start wrapping this thing up. Now, we're going to put a Smilodon under our end credits for today. In honor of California, where I live. That's our state fossil here in California. And who else is streaming live on Twitch right now? Oh, it would be very appropriate, I think, if we would raid into Rocket Sage right now, because she is a geologist herself, and we've been talking about geology. Raid Rocket Sage. There we go. Lovely. Good stuff. Everybody, thank you so much. Everybody who's appeared here in the credits, from those followers like you, Ken PDX, to subscribers, question askers, lurkers, viewers, chatters. Thank you, everybody, for a wonderful stream. I really hope you had a good time. I hope you learned something. I hope you're excited to see more of our Allosaurus come together on Monday, because I will have more 3D parts printed by then. I'll be printing more on Monday, too. And we were talking a lot about earthquakes, about disaster preparedness, about how society deals with these things. Sage is one of those people who is herself a professional geologist. She'll be able to talk about this with you a little bit if you have any questions, in more detail than I will be able to. So let's go check in with Sage. Thank you, everybody. Have a wonderful weekend, and I'll see you next time. All right, bye-bye.